This conference will now be recorded.
We are Stalwart Learning. We are about a 1.5-year-old organization, and we are basically into learning solutions for various organizations across India. Right? We deliver various e-learning and technology as well as soft skills training programs to organizations across India. Right? So we have a partnership with an organization called Skillsoft, which is one of the world's leading e-learning organizations, and we provide 7,000 plus courses, 65,000 plus videos, 46,000 books and ebooks around various topics like technology, business skills, technology and collaboration, etc. We also have a partnership with another organization called Chart Learning Solutions, which is into primarily e-learning on the soft skills areas, primarily promoting on the blended learning side of things. We also have a deep expertise on the instructor-led training programs and have expertise on areas like DevOps, MLAI, data science, testing, programming languages, cloud computing, etc. We also deliver various certified training programs in agile, process-oriented programs, cloud computing, project management, etc. We have a good expertise in the soft skills training side of things as well. We deliver programs such as business skills, conflict resolution, first-time managers, etc. In terms of the modes of training programs, we do deliver e-learning, instructor-led classroom, and instructor-led online programs. And we have curated programs for participants from various levels, right? Including fresh grads, laterals, and senior participants. In terms of the clientele, we are serving more than 60 organizations across India with their training needs in technology, soft skills, and e-learning areas. I would now request you to make Ritesh sir the presenter for the program so that he can go ahead and start his technical session.
Thank you, Abhay, for the introduction.
Thank you, sir.
All right, so I'm just going to share my screen. Okay, guys. I have to adjust my screen a little bit. Hi, guys. My name is Ritesh, and welcome you all for this webinar for Docker and Introduction to Kubernetes. So let me set the expectations before we go ahead. And let me set certain rules also before we go ahead for this session. So this is actually a webinar, and the purpose of the webinar is always to give you the technology information in terms of what is the technology, why that technology is required, what is the purpose of the technology in the market for quite some time, and why that is the hottest thing in the market, and what kind of applications and development and deployment infrastructure activities are done by the technology stack. So the purpose of webinars are different from training. So I would just want to set the expectations before I take it ahead. That this is a webinar to give you an overview, and so that you understand the technology from some perspective. If let's say, for example, you are right now zero about this technology. So the purpose of this webinar would be, after sitting 2-3 hours together, you should be able to grab something from here, so that you have in your mind that, okay, this technology stack is used for this purpose, why Docker, and how do we use Docker a little bit, and purpose of Docker. So don't take it as a training actually, because in training we talk about the technology as a whole, from basic to intermediate to advanced level. We talk about each and every concept theoretically, conceptually, practically, and any trainer will teach you any technology from the perspective of that you have to become the master of that technology. So here, let me set the expectations, guys. So take it just as a simple introduction overview session for Docker, so that and take it like that you came here to understand this technology and how to make use of it, and understanding it from the perspective of your day-to-day needs. And in the future, if you want to go ahead in detail, so definitely every technology has full-fledged training sessions, or you can do self-learning, because Docker is a big thing and Kubernetes is a big thing. So that is the expectation. I want to make sure that everyone should be basically joining this session from that perspective, not from the perspective of as a training session. So I will just keep on explaining, and maybe in 2 hours or 2.5 hours, you should be able to grab a lot of things about Docker, container, this technology, etc. So that is about the expectations, guys. So make sure we are on the same page. That is first thing. And then there are certain rules. I would request everyone to go on mute, because I can see around 95 people have joined already, and there will be more joining. So definitely everyone has to be on mute and just have to listen to me and have to hear me, as well as whatever things I'll be doing on my system from this perspective of this technology. And if you have any questions, guys, there is chat window around. You can see there is chat window here. So in the chat window, you can just raise your questions, or there is no problem. Even if you want to have a voice chat, you can have a voice chat also. You can call also for your questions if there are any. But I would request you to have your questions at the end of this session, because I'm planning till 12:45 to give you the knowledge sharing session. And after 12:45, we will have a query session, question answer session, wherein your questions will be answered. Maybe you are using voice command, or maybe you are using chat window. So that is the expectation, guys, from my side. So let me just start from now. Okay, Chaitanya is asking, will the presentation be shared at the end of the session? Yes, Chaitanya, presentation would be shared. And it's not about presentation, there will be examples also. There will be examples also which you can just take. Recording, I don't know who's making the recording. I'm not sure who started, who's the organizer of the meeting, and
yeah,
who started.
Recording would be shared.
Sorry, I didn't hear.
Ritesh Roshan here. So recording would be shared with all the participants.
Okay, fine. So because one of the guys asking.
Yes.
And guys, one more thing, that we have every minute, every hour very precious and very important. So I would request all of you, don't take it as a granted. Don't take it for okay, just we will sit idle and in front of the system for 2 to 3 hours. And so guys, if you really want to learn here, so even in 1 hour also you can learn certain thing, and in 2 hours also you can learn certain thing. So what my point is, be honest, be attentive, listen to each and everything very carefully, so that you can make out of this webinar as much as you can. And you can make your decisions after this webinar is over. So make sure you are fully attentive, and make sure you keep asking your questions, and I'll make sure that this session is going to be interactive with everyone. All right, guys. So let me just go ahead, and right now I'm going to start. It's around 9:45, and 12:45 we will end the learning, and after that we will have half an hour session for what do we say, for questions and answers after 12:45. All right, guys, let me just go ahead. Let me give you the agenda. So I told you certain rules, so make sure you just stick to those rules, guys. My screen. Okay. All right. So I hope, did I share my screen to you guys? Can you see my screen? Anyone can answer me by saying yes or no?
Yes.
Okay,
Yes.
cool. All right, guys. And I would be considering all of you as a layman for this technology, whether you're already working on Docker or not. But for me, you will be absolutely new and absolutely zero knowledge for this technology stack. So I'll take from zero and I'll go up to some examples. So this is a webinar on Docker today. So this will be the agenda, guys. You can see we will learn here what is Docker, and virtual machine, the differences between them, history, status, run platforms, on which platforms Docker can run. We will see hello world kind of containers, not hello world kind of beyond that. We will see images and containers. We'll see what is volume mounting, port publishing, linking. What is the Docker ecosystem around Docker? What things are available in the market? What are the Docker proper use cases in the market? When to go for it? And we'll see some sample like container examples here. We'll create them, and definitely little bit introduction to Kubernetes. That much we can do in 2 to 3 hours. That is going to be the agenda we have today. All right, so let me just go ahead from here. So, right, if you talk about what is Docker, so as you can see on the screen also, it is actually an open source project that is actually used for the deployment of applications, and it provides an abstraction layer for the application so that there is no dependency on the underlying operating system. So let me explain you in detail actually what is Docker and what is a container. So we'll just go a little further from this slide. We'll go a little further. So I'll not show you just slides and slides. I'll take you with some practical examples also. So guys, I'm just going to create for you guys some notes which I'll be sharing. Let me save this file here. I'm going to save this file for you guys. So I'm creating it as Docker notes. I'm just saving it on the desktop. So if you ask me what is Docker, so, and sorry, I forgot to mention one thing which is very important. For this learning, for this teaching, I'm expecting that guys, you have some knowledge about past development knowledge, or maybe you are having some development background, maybe you are from the infrastructure background, maybe you are from the system team background, and definitely a little bit Linux knowledge is required. So make sure you all meet these requirements, because when I teach you certain theory, certain concept here, and when I teach you certain examples here, if you do not meet these requirements like working on Windows operating systems, working on Linux operating system or Mac operating system, and basic concept about Mac and Windows, so I'm sure about it you will learn nothing. Even if this session is for 3 hours, 3 days or 5 days, this will not help you at all. So these are the prerequisites. Make sure you have basic Unix knowledge, what is Unix operating system, how it works, what is the architecture of Unix, and basic Unix commands like pwd, like ls, like cd, like cp, like mkdir, etc., and Unix directory, Unix operating system directory structure, and definitely different operating systems. And you should be from some development background also, so that is going to help us. So make sure you meet these prerequisites before I go ahead. All right, so let me go ahead. Let me tell you what is Docker. So guys, Docker is a container technology. A very simple definition of Docker. Just container technology. What do you mean by container technology? Container technology means Docker is used to, guys, remember, as we know it's a webinar, so I will try to explain you in very simple, plain layman terms. I will be less technical. I'll not go more in technical details. I'll be on layman terms. I'll try to make things understand in such a way so that you can grasp things as fast as possible and as much as possible. Because as I told you already, if it was a training, everything would be done technically, and each and every technical detail will also be discussed. But here, let us learn it from the purpose of the webinar to understand what is Docker, why do we need Docker, and how to use Docker with some examples. So guys, Docker is a container technology. Docker is used to build and deploy any kind of applications. Docker is mainly used for shipping applications from places to places. And I hope we understand the meaning of places to places. When you are a developer, what is the meaning of places to places? I'm not talking about physical places. I'm talking about machines. I'm talking about systems, because we work on systems as developers. So system is for as a place. So any application which you create, if you want to ship them, so Docker can help you very quite easily. That is the main purpose actually of Docker. How Docker is mainly used for. Docker is going to make day-to-day infra operations easy. What do you mean infra operations? You will understand sometimes. Docker is based on build once and run any and everywhere. That is the main purpose of Docker. Build once and run any and everywhere. Any application you build, run once and any and everywhere. Docker is a technology based on Linux kernel-based environment. So we can understand when I say Linux is a technology based on Linux, this Docker is a technology based on Linux kernel-based environment. So we can understand like how important it is for anyone to learn Docker. Before that, you have to have knowledge about Linux and how Linux operating system works, and what is the Linux kernel and Linux file system. So make sure you have good knowledge about Linux. So it means Docker containers can run on Linux operating system, but today they can run anywhere. Docker mainly helps you bundle application code and dependencies together. So guys, sorry for typos. Typos would be there, so just forgive me for that, because I'm just typing about not worrying about typos. So it will help you to mainly bundle application code and dependencies together. So if you don't understand these points, not to worry. When we do some practical examples, I'm sure about it, you will understand each and every point. Right now I'm writing some points you may understand, some you may not understand, but wait, you will understand all of them once you see some practical examples. Mainly used to bundle application code and dependencies together. Docker is used to build reusable and shareable containers. Containers inside containers. Shareable applications inside containers. Docker is a lightweight technology compared to VMs. Because before Docker was not there, once Docker was not there, so we used to use virtual machines for our virtual technologies. One thing I forgot to mention, Docker comes under virtualization umbrella. What do you mean by virtualization umbrella? So basically, we have physical hardware. On the physical hardware, you can install your things, or you can have a virtual machine. Like there are a lot of virtual machine today. You can use VMware as a virtual machine. You can use VirtualBox as a virtual machine. You can use parallels. Like on Mac machines, we use parallels. Like on Windows and Linux machines, we use VirtualBox or virtual machine as our virtualization technology. So actually, Docker is a virtualization technology wherein you create your virtual machines on top of physical machines. So from that perspective, it comes under virtualization umbrella. But being a virtual technology, it is actually not a virtual technology. It is just a container technology. And I'll make you understand the difference in virtualization technologies and container technologies. But container technologies come under the same umbrella, which is virtualization technology, like VMware, VirtualBox, Parallels. They all come under virtual technologies. That's why we call them VMs, virtual machines. And I'm sure about it. If you have been developing applications for quite some time, so I'm sure about that you have already used some virtual machines in the past on your home PCs or on your what do you say, official PCs wherein you develop applications. So guys, these are enough points about Docker as what Docker is all about. So it is actually a technology which is used for that. So let me tell you from the perspective of why the name is Docker and how it comes to be as a container technology. So as if you talk about old-fashioned, see, the old-fashioned was that. The old-fashioned was this. As the old-fashioned developer will create and package application and share it with the client. That is what we have been doing in our software industry for last 50 years almost. Any application you create in Java, C, C++, Scala, Groovy, or any other language, ASP, Servlet, ASP, .NET, PHP, whatever technology stack you are using, once your application is ready, you will package it, and after packaging it, you will share that application to your client by a lot of means. Maybe you will create, if you are in Java, you will create a jar or var or rar file, or maybe if you are in Windows operating system or .NET, then they will definitely create exe or DLL or cap file, then you will share to the client. That is old-fashioned. So there, after you have sent your application through some means, maybe through some mail, maybe through FTP upload, maybe through some common URL for file sharing URL, which is already shared by the customer. After that, what customer will do? Customer after that has to, on the client side, or customer side, will set up machine and required software will be installed to run the code the given code or the given application. Given code or application. That is what used to happen old way. If you talk about old days, but guys, when these container technologies came, things have changed. Now, how things have changed? What was the pain area here? If I ask you, what is the pain area here? So guys, I'm throwing one question to you. This is question number 1. Yes, guys, this is a question I'm throwing to you. Anyone can speak out randomly, or anyone can give me the answer.
So one of the pain area is that, okay, like we develop the application for some of the software and we ship it to the client, okay, and then when the client set up, they miss some of the configuration, or they are having some different softwares installed over there. So it would be one of the main pain area, which I guess.
Absolutely. Have our technical infra team. What you are saying is correct. So we need to have our technical infra team available on the client side. If there is no infra team on the client side, the software you have shared, the code you have shared is of no use. What you are saying is correct. So there is a lot of investment required. There are more people required. We need to have a dependency on those guys. First, they will set up Windows machine, Linux machine, and definitely then required software would be installed, and then only the code which is shared will be in use. Otherwise, not. So what you said is correct. That is big pain area, investment involved, people involved, delay is there always, like that only. And many people are giving answer configuration at client side, good, making sure all the required dependencies present on the client machine, exactly, platform dependency, more manual effort required, absolutely fine. So a lot of people already know about this pain area, so the questions, you are already giving answer, that's cool. And someone is asking, what do you mean by container? So wait a little bit, we are moving towards that. Nikhil, we're moving towards that only. I'm just starting, so we will move towards that and you will understand what is a container. All right, cool. So question answered. Now new question. So guys, what we want is we want to minimize those pain areas. So what do we want actually? Our requirement today has changed. We are looking for today's developer will create package and will create package and bundle code with dependencies and softwares in a container. Again, same thing. Many of you who are very new, they will not understand this terminology right now. What is a container? But don't worry. Slowly it will be answered in a container. So that is a new question today, guys. So as a developer, you create your application, package your application, make it jar, var, rar, whatever you want. Bundle the code with all the dependencies and all the softwares which are required to run the code in the container, and then ship the entire container. Ship the entire container. So that is the new question which we actually have been doing. What that container is, we will just understand. So the benefit would be on the client side, system team, client side, system team is not required. Client side guys can simply run the entire app in a fraction of seconds without having any manual work or preparing lots of things in advance, lots of infra things in advance. The only thing required is the on the client side is the software to run the thing. That's all. So that is beauty, guys, about the container technology. So that is what. See, client side, we don't need a system infrastructure team or infra team, or we don't need to prepare a system in advance. We don't need to download software A, software B, software C, and we do not have to do this preparation. Okay, for running, let's say, for example, if it is Java code, I need to have this jar in advance, or that jar in advance, or this particular dependency in advance. We don't need them. So that is the beauty. Simply, entire application will be run, and that with the help of that container, and whatever software will be required to run the container, I'm just going to tell you that. So that is a very new way of guys working with our latest trend in the market is this one only, container based technologies. So when you talk about how it works, so basically guys, this is where actually we need a container based technology, and that is what is actually Docker. So Docker is one of the container-based technology. Before Docker also there were many container-based technologies available. Like we were having in Solaris we were having jails, in Linux we were having LSX. So there were many container-based technology, but they did not succeed. They did not become popular. They did not become very successful. They did not become very successful, but Docker became successful. There are many reasons. I'll tell you those reasons also. So if you ask me what is Docker, so guys, Docker is very simply just like a container. For example, now let me explain you from a manual point of view, from a layman point of view. For example, like if you remember, guys, old time in the real world, around 40-50 years back, we talk about in real world. I'm talking about, not computer world. Let's say you want to ship some items from place A to place B. Let's say, for example, you have some tomatoes or potatoes, or maybe you have some rice, or maybe you have some wheat, or maybe you have some onions, or maybe you have some sugar to transfer from one place to another place. So you can understand in old days how it used to happen. Okay, let me have all these items on different transportation available in the market. Let's say let me use trucks, or let me use buses, or let me use e-rickshaws, or let me use rickshaws, or like that only. Let me place tomatoes, or maybe potatoes, or maybe certain goods or certain things in buckets, and then those buckets will carry them. So there was a kind of a haphazard kind of thing. There was nothing like a streamlined way of transporting things from place A to place B. And the problem is, what if in between you have to switch your that means by which you are transporting. What if in between your the transportation you are using is basically not working on the way, and you have to transfer the entire luggage or entire goods from one transport to another transport? How difficult it is to individually picking from one transport and individually dropping into another transport and then taking them ahead. A lot of things are disturbed, a lot of things are broken, a lot of things are spilled out, a lot of things are left out. There is no proper way. Things were kept here and there, they were in proper way, but when you transport it into another transportation system on the way, like for example, from place A things started in a rickshaw, but in place B they have to be transported in a tractor trolley. From there in place B they have to be transported in a truck, and then place 4 they have to be transported in a aeroplane, like that. So things will not reach the right way like they have to reach. So what I'm talking about is, guys, like in real world we have the concept of containers. Like if you go to any dockyard, there are a lot of dock containers we have on the dockyard. Inside the container sizes are fixed, and inside the container what luggage is there, that is not your concern. Inside the container luggage can be anything. What you have to do, what about is that When you have your luggage inside a container, you don't have to worry about what is inside the container. The only thing is that you have to ship your you have to shift your container from place A to place B without worrying about what is inside the container. So it becomes easy. Shifting from transport A to transport B becomes easy. Things broken are not there. Inside the container, what luggage is there, what goods are there, that is not your concern. So it's just a very streamlined way of transporting things from place A to place B, because almost containers provide the same environment. Containers almost provide the same, same size. Containers have a particular, shape, like square shape, or like, for example, rectangular shape. There are particular arrangements like we have. So that is how things are happening in the real market, and the same thing has been adopted by our software industry also. And one more thing, one more benefit of container, guys. Container does not only help you to ship the code, that within the container there will be code, and then code will be shipped from place A to place B quite easily. Container will provide the environment also. So container, if you ask me, container means code plus environment, two things. That is very important. Code plus environment. Earlier we used to ship only code, but today we are shipping code plus environment. Environment means, for example, if I write some Java code, I write my .java file, I compile it, I have a class file, I share it with you. It is of no use until you have the required environment in your system. Code I shared, fine. But what if you don't have JDK installed in your machine? What if I share some JavaScript file with you? What if you don't have Node.js installed in your system? What if I share some C++ file and you don't have C++ development kit installed in your system? So I'm talking about that environment. For example, I share a WAR file with you, web application developed in JSP and Servlet. I write it and it is ready. I want to give it to you. I gave it to you. You want to run it. And while running it, you don't have available web server with you. There is no Tomcat with you. There is no WebLogic with you. No WebSphere server there is. There is no JBoss server. So you need to first install JBoss or WebLogic or the Tomcat. And for installing that, you have to install first JDK. So that environment I'm talking about. If your application needs some JDBC driver, those jars need to be arranged. If your web application need to talk to some database server for fetching data, then database server has to be installed. So you can understand, creating a web application is not enough, or an application is not enough. Where is database server? Where is Tomcat server? Where is JDK installed? Where are all these things? So I'm calling these things environment. So today benefit, guys, is forget about old days like create application and package application and share it. That is what we have done already in the past for a long time. But today we have to just develop, package, and bundle the code with all the dependencies and all the softwares inside the container, and then ship the entire container to the customer. So container is nothing, just container will carry your code and environment together. Like in real world also it happens. In real world also it happens. If you're transporting some vegetable items in a container through some by air route, or maybe by ship route, or by water route, and the journey is of around 10-day journey, so that container has to have a refrigerator inside, and that refrigerator has to provide a proper cooling for those vegetables, so that vegetables don't just go waste by the time they reach. So sending goods, sending code is not everything. Providing proper environment on the way is also very much important. So like in real world, our containers on the dockyard, they provide proper cooling environment, proper warming environment, proper airy environment, and proper compartments inside, so that the goods can be transported with proper environment as it is in a proper shape to the destination. Same way today we have containers in our today we have got containers in our software industry also, and that is what is a container technology. So that is where it is originated, guys, and that is why the name is Docker also. Docker means it's just a container, like we have on dockyard. We have containers, so the name has been taken, actually name has been inspired from there only. On dockyard we have containers, so this Docker technology will help you to have your containers, which can be which can help you to have your code and your environment together. So things have become easy with the help of Docker from that perspective. So if you now go ahead with this slide which I was showing you, so here, what is Docker? So just read this definition now. You will be able to understand a little bit better when I was talking about this, after understanding those points. It is an open source project that automates the deployment of applications inside software containers by providing an additional layer of abstraction and automation of the operating system. And definitely it's a virtualization technology based on Linux kernel, as I told you already. Docker, this name came from where? Just see where this name came from. You can see the image. That's an original image, official image, which is available on the Docker site also, docker.com. Who is behind this technology? So you can see if you see there is a whale, if you see the Docker image, there is a whale, and that whale is having many containers on top of it, 1, 2, 3, 4, or all of them are of equal size, but we don't know what is inside those containers. And that is the beauty. What software, which container has Node.js, which container has Java code, which container has C++ code, which container has database, just container. When we will reach the destination, the guy on the destination does not have to worry about what container contains. Simply we'll pick the container and we'll run it. That's all. Whatever is inside the container, that will execute. So you can see provide a uniform wrapper around the software package. So build, ship, run any app anywhere. So similar to shopping containers, the container is always the same regardless of the content, and thus fits on all the trucks and trains and ships and like that. And that's what I was also trying to make you understand. So this way it becomes easy for you guys also to work with that. Now guys, next thing. Before Docker container was there were virtual technologies in the market, like virtual machines in the market. Now the question is, like virtual machines, for example, we have VMware, like Oracle VirtualBox, like Parallels, like these VM technologies. They also used to do the same thing, like on a physical operating system like Windows or Linux. Let's say I have a Windows machine. On that I want a Linux machine also, and Mac machine also, and one more Windows machine also. So one physical machine I can use as 4 operating system, one host operating system and 2-3 guest operating system. So each guest operating system can be installed into a separate virtual machine, and these are the software to have virtual machines in the past. So as such, they were also virtual machines only. The physical machine was one, physical operating system was one. On that physical operating system, we can install OS 1, OS 2, OS 3 with the help of these virtual machines in the past. Now the question is, if we can install virtual operating systems or guest operating systems on top of host operating system, and on those operating system we can install our softwares and we can install our code also, then why do we want container? What is the difference? So guys, the difference is quite obvious. When you talk about these VMs are actually quite heavy in terms of size, and they differ a lot. The main difference in VMs, and container technology is VMs are actually providing hardware level virtualization. They're providing hardware level virtualization. If you talk about VMs, but if you talk about Docker and containers like Docker containers, they are providing OS level virtualization. That is where the big difference comes. This is the main big difference we have. A lot of differences are there, like which are heavy, which are lightweight, which are faster, which are slow, which consume more memory, which consume less memory. There are many more things I will explain you. So container like Docker container are providing OS level virtualization and hardware level virtualization. Means a physical machine has around 16 GB RAM. There are 6 to 8 CPUs. There is a motherboard available. There is a hard disk available. So the entire hardware will be divided in each operating system which is running on the same machine. I have an original operating system. On top of that, I installed operating system 1 and operating system 2. So total operating systems are 3, 1 physical, which is host, and 2 virtual, which are guest. So they will divide equal amount or whatever you decide. The proper hardware division has to happen. So that's a hardware level virtualization. But Docker containers are not providing OS. They're not providing hardware level virtualization. They provide actually OS level virtualization. Means just look at this screen here right now. If you look at the difference in Docker and virtual machines, both of them are virtual technologies. Just see here. If you look at the right side screen, so we have our main server, like for example, I have a Windows server or Linux server right now. That is my host operating system. On that server machine, my host operating system is Linux, or let's say Windows operating system. Then they use a technology called Hypervisor. That Hypervisor is actually a virtualization technology which should be supported by all the underlying hardware. If the underlying CPU does not support Hypervisor, then this VM or virtual machine concept is not possible. So, and definitely nothing to say today. Today, everything. And on top of that, you can see we install guest operating system 1, guest operating system 2, and that guest OS, maybe one is Windows OS, one is Mac OS. Then it will have its own bins and libraries, and then you will be able to deploy your application A and application B. Just to deploy application A and B, you first brought your libraries on both the machines. You installed you did proper installation of 2 operating systems. Like if you take 2 hours to install one operating system, original one, so you will need 2 hours to install these operating systems. After your operating systems are ready, then only you will be able to, they are virtual, fine, but being virtual, you are actually installing operating system, then you are installing required software like Java, like C++ kit, like Groovy kit, like Tomcat, and then you are actually running your application. So it is a complete end-to-end working, just not just like a feeling. Actually, you're working with just like a physical machine. That is a matter of the fact that the same hardware is supporting more than one operating system with the help of hypervisor technologies which are there. So you can say every CPU supports today virtualization. So that is what used to happen earlier with the help of VM technologies like VMware or VirtualBox or Parallels. But if you see today on the left side here, when you want to do the same thing, I want to run application A and application B on the same machine. So see, on the original server machine which I will have my host operating system. Let's say I have a Windows operating system. The only thing which I need to install is something called Docker engine. So if you're installing Docker, so I told you to run Docker containers, you need a Docker engine. So Docker engine software you have to install, and the Docker, on top of that Docker engine software, you can just install your bins and libraries required for application A and bins and libs which are required for the application B. So you can see that is quite clear here. So what is missing from this image is you actually do not have to install separate operating systems for separate applications. The one single operating system is good enough to basically to run multiple containers on the same operating system. So each container, the main difference is each container will share the file system space, will share the same operating system memory, will share the same operating system CPU, will share the same operating system hard disk, and the same operating system resources would be required and will be shared by each container in such a way so that they do not disturb each other, they do not know each other. So from that perspective, they're going to be lightweight. There is no need to distribute the underlying CPU, underlying hardware, underlying hard disk, underlying memory, okay, 2 GB and 2 GB and 2 GB or 2 GB, 3 GB, or let's say for example, 2 CPU to one guest operating system and 3 CPU to another guest operating system, or this much hard disk size to one operating system, or this much hard disk size to another operating system. That used to happen in virtual machines, and that is why they were heavy in terms of setting up them. It will take original amount of time like it takes for a host proper operating system. But today, using container technology, you don't need to install any operating system, only the same operating system is enough. So Docker engine, which is a software which provides an abstraction layer on top of the same operating system, so that multiple applications or multiple projects you can run on the same operating system, just like they are running on different operating systems altogether with the help of Docker engine. So you can see clear cut that there is a difference in terms of size, in terms of installation efforts, in terms of memory, in terms of resources, and every container will run on the original host operating system. There is no guest operating system, so one layer is absolutely missing, and that's why it becomes easy for you to transfer the container from one place to another place, because the efforts are less. The only requirement is that there should be a software available called Docker engine on whatever machine on which you just want to run a Docker container built on machine A can run on machine B or machine C or machine D. when Docker the Docker software is available on that particular machine. So that is the difference in containers and virtual machines, which we used to have earlier and which we have today. Basically, it is just giving a difference. And if you talk about Docker as a technology, so we had containers in the past also. We had in containers in past. So see what the technology which is used for platform virtualization, Linux containers. We in Linux we already have LXC containers, which are not very popular. A long time back, they were used by Linux operating systems very well, but they were not very popular. So container is not a new technology; it is actually old technology. But because of Docker came in market and it made it popular. So I'll show you some next slides wherein you will understand why it made it more popular and why container technology became so famous, so popular that everyone is talking about it. Because it has just one liner I can tell you right now. It has taken container technology to internet and to cloud and to in the hand of developers who are having very low hardware and very low bandwidth and very low resources on their machine. So this technology has taken containers up to those points. And Docker technology is based on layered operating system. So you can see here, this is an example. So Docker containers are based on Linux kernel. On to Linux kernel, there will be base image, then one more image, and then you will have a container on top of that. And Docker, little bit history about Docker, started in 2013, then Red Hat collaboration happened in 2013 only. Then GitHub project started in 2014, supported Docker. And definitely then this container technology was awarded in 2014, and after that it has been very popular. This is just a history. So history is just nothing but it started in 2013 actually, and then it was adopted by big giants like Red Hat collaborated, and they started using it quite heavily, and from that on time onwards it started using in the entire open market. And if you talk about Docker containers, so Docker containers can run on various platforms. They can run on various platforms, like they can run on different Linux distributions like Ubuntu, Fedora, CentOS, etc. And that is another benefit of Docker containers. They can run on different cloud like Amazon, like Google Cloud, like Azure Cloud, Microsoft Azure Cloud. They can run on those clouds like Pivotal Cloud. And another benefit is Docker containers originated based on Linux kernel. They need a Unix operating system or Linux operating system to work with Docker containers because they are actually based on core technology, which is Linux. But Microsoft also changed the internal architecture of their operating system to accommodate this Docker as a technology so that Docker can run on Windows platforms also. So today, Microsoft operating system also supports and Microsoft platform also support Docker technology well. You can create Docker containers on Windows servers also, but not to all the machines. Like all Windows 10 machines, you can run Windows 10, let's say Enterprise Edition or let's say Professional Edition or Education Edition or 2016 server Windows, you can run Docker because Docker has integration with Microsoft now, and Microsoft has changed their internal operating system architecture to make it just like Linux architecture so that it works like a kernel. So Microsoft Windows operating system kernel has been refactored, restructured, so that Docker container technology can be used with Microsoft system also. That is another good news. So that is another benefit. You write a container on one machine and you can run it on another machine, maybe Linux machines, Mac machines, or maybe any cloud machine like Amazon, like Google Cloud, like Azure Cloud or Pivotal Cloud. So there is no limit on wherein you can run them. So guys, this is a big deal. What if in the past you just for the sake of running a var jar file, you created a virtual machine like Linux virtual machine, you installed operating system like guest operating system within a virtual box machine, and then you installed required Tomcat and JDK and all, and then you install your var. How can I run that infrastructure on a different machine altogether? How can I take it on a different machine altogether? How can I ship it to a cloud altogether? How can I give it to my testing team? How can I give it to my production team? How can I give it to my staging team? How can I give that infrastructure which I set up to a new developer who just joined my team today, and I want to share my setup with that guy also? How can I make that guy, that new developer who joined my project in next 1 minute ready to use the entire infrastructure? So these are a lot of problems and limitations we have with our virtual machine technologies. Even they support what they provide virtualization. Still, these are a lot of limitations which you have So because a virtual machine is too heavy by size, in terms of size, because there is first operating system, then software, then code. But in container, no operating system, only required libraries and jars, or maybe software and code. So operating system is missing. That's why the container by size is very lightweight, and because they are supported by cloud and a lot of machines, so from that perspective, they're shareable and they're distributable. They can run a lot of platform. That's a big benefit you have. So guys, why Docker containers became very popular? So these are some of the features of Docker which you can see right now. These features made Docker quite popular, quite productive in the market. Like for example, ease of use. So developers, system admins, and architects, they can learn them very easily. I will also show you here in this session only. I will show you how to create a Docker container and how to ship an application. I'll show you 2-3 examples. Speed wise, they are quite fast because Docker containers are quite lightweight and fast. Reason is they do not have, like in a virtual machine, you always have an operating system first, then software, then jars and vars and rods. But in a Docker container, you only have your jars, vars, rars only, code only with the available dependencies. There is no operating system. That's why they are lightweight and that's why they are fast. There is another benefit. Docker community has their own Docker cloud URL called Docker Hub. So through cloud URL, you can I can upload my Docker container on cloud, which is a Docker Hub, and then you can download from there. So sharing becomes easy. That is a very big platform where a Docker community meet, and I'm going to do that in this session only. I will create a container. I will share with all of you. I'll tell you from where you can download and you can run. And when you will download and run, you will see in your machine you do not have to install any extra software. In the container, I will give you everything, not just code. And then I will ask you 2-3 questions, you will understand the benefit. Modularity, that is another benefit. Yeah, I can create 2-3 containers, one container holding DB, one container holding web server, one container holding code. And I can make all the containers talking to each other, communicating with each other. So they are modular approach they are providing me. So I can have individual containers holding only individual facility, individual feature, individual capability of my entire project. So that is another benefit. So let me make them live rather than installing all software, all jars and vars in a single container. Why not to have separate container for database, separate container for JDK, separate container for web server, and let us install small things and only very required things in separate containers. So that make them modular. So, and that make them reusable because they become reusable immediately. Rather than having everything together in one container, that may not be reusable because if someone is needing only database, and I created a separate container only holding MySQL database, only holding Oracle database, so that container is reusable from that perspective. So make sure your containers are modular in terms of don't install a lot of things in single container. Keep containers modular by having them single software or the logical softwares grouping of softwares. Scalability, guys. Scalability is another benefit. For example, that's a very big advantage. Number of users who are using my database today, MySQL database, I have installed MySQL database in a container. Number of users are 1,000 and application is working well, database is working well. But when the number of users to my database becomes, let's say 20,000, and one MySQL instance says that I cannot handle more than 2,000, 5,000. So guys, so easy it is. The same MySQL container I have, I will run multiple instances of that same container. I will run multiple instances of MySQL container, instance 1, instance 2, instance 3. The more load will increase, the more container I will start within a fraction of a second, just by through some CLI command. No installation would be required, no separate installation, no separate virtual machine setup. It's just a matter of, okay, I have my container ready, let me start one more and one more and one more and one more within a fraction of a second by using some commands. So that way, scalability can be achieved well. So you can make your application scale well. It can be scaled up, it can be scaled down. And then portability we have. Containers are portable from Windows to Linux to Mac to cloud to Azure to other operating systems, other cloud environments. They are quite portable also. And there are many more facilities we have in the as a part of Docker features. These are the features, guys, which make Docker as a technology quite popular for in compared to previous technologies we have for containers. And this is just a little bit about the architecture of Docker architecture. Docker client will talk to Docker host, and Docker host will basically talk to Docker registry. So let me make you understand what this is, and then I will show you some examples so that actually you understand what I just discussed with you and what you can just understand from there. I got some questions here. Why do we go for virtualization when we can expose our application using microservices? Okay. Is Hypervisor a software or hardware? All right. Docker engine have their own CPU and memory. Okay, let me give you these answers one by one. The question number one from Deepak: why do we go for virtualization when we can expose our application using microservices? Deepak, answer is very simple. Mike, I hope you can hear me. I'm giving the reply to you, Deepak. Even microservices itself are shipped within a container. So if you talk about microservice we have, why do we need virtualization? So the answer is very simple. When you build a microservice, that is actually code. So to ship your microservice, to deploy your microservice, to share your microservice itself, the best combination today is a container only. So virtualization technology is still required even if you have microservice. For example, if I create a microservice on my physical machine today and I want to share it with you, I cannot. Because if I share my service code to you, I'll share code. But again, you have to install that software or those things on your system which microservice requires to actually run. And if you say that microservice contain everything together, microservice will have everything together, let me tell you, that is just a myth. Within microservice, we don't have everything together. For example, to run microservice, you need Maven. Let's say, for example, I do not have Maven. To run microservice, I need to have in my system, for example, JDK. I do not have JDK available. I built a microservice using Boot, Spring Boot, or I built a microservice using Photon, or I built a microservice using, let's say, Eclipse microprofile. And when I give my microservice to you, in your machine, there is no JDK available. You can't run it. Environment is missing. Dependencies are missing. So even for shipping microservices with their environment required, we still need containers. So I hope you got your answer, Deepak, for microservices. So we have microservice best combination with the virtualization technologies and especially containers only. So today we are using Docker containers quite heavily when it comes to shipping microservices. Okay, so question number 2, is Hypervisor a software or hardware? Yeah, Kamal, the answer is both. Hypervisor is basically a hardware technology as well as a software technology also. It comes as a software also, it comes as a firmware also, it comes as a hardware also. So it is used in all the 3 layers: hardware level, hardware layer, firm layer, as well as software layer. So all the 3 layer Hypervisor is used. So that is the answer to your question. Now, Nikhil, Docker engine has their own CPU and memory. No, Docker engine is a software. Nikhil, this Docker engine is just a software, nothing else. There is no fund of CPU and memory. It's just a software. But what you can do is, when you set up a container, to the container, you can set the maximum memory it will occupy. That is what maximum you can do if you want. That my container should not occupy more than this memory. Then there is a question from Dheeraj: is Docker engine needs to install every time in environment where we need to push it? Yes, definitely. If you are giving a container to me in my machine, Docker engine has to be there. Otherwise, that container is of no use to me. Docker engine has to be there. Here's that is the answer to your question. If there is no Docker engine, there is no software available. Definitely, you cannot. It's just like on a dockyard. If there is a container and there are no cranes to push it or to pull it or to lift it, there is no benefit of those containers. So creating a container is a good thing, but there have to be cranes around to handle those containers, to ship those containers, to execute those containers, to use those containers. So Docker engine is just like a software, which is just like crane. So we need Docker engine to be there. And a lot of questions I'm getting, so I can give the answer right now, but I would suggest you one thing. Just if you can hold your questions, guys, till 12:45, I would suggest you, because I have already told you in the beginning that let me complete this webinar, let me give you some examples, and then we have a complete half an hour for question answer only. So I would request you, if you can hold your questions till 12:45. I will give all the answers. Questions I have seen, I can give you answer right now also. So just wait I will give these answers, whatever questions I have, 2, 3, and then hold your questions, guys. We will have them separately because otherwise I'll not be able to complete my agenda because I need to show you some examples also. Let me give these questions answers, which I already got on my screen right now. Because ask a question, we are deploying our application to production using CI/CD pipeline, so still we require Docker. Okay, because the answer to you is that CI/CD pipeline itself is set up within a Docker container. You are talking about CI/CD pipeline set up on a physical machine, but actually the best combination is that CI/CD pipeline setup itself should be within a Docker container. If you go that way, then definitely your CI/CD pipeline can be deployed on cloud also. That is the beauty. But if you have set up the CI/CD pipeline using Jenkins, like using Bamboo software, using many softwares are there, like Jenkins is there, Bamboo is there, and Cruise Control is there. So if you do it on a physical machine, then definitely that CI/CD pipeline will be limited to only that machine. You will never be able to do that setup on a separate machine, your Kulika machine or some client-side machine. Better to do that CI/CD setup within a container of Docker, so that you can share your CI/CD pipeline with anyone, anytime, using just Docker engine as a software. That is the answer to you. Choice is yours. You want to go with Docker or not, but better is to go with Docker. Another question from Nirmal is container available for MS machines currently? Yeah. For Windows, we have got container available from Windows 10 onwards. In Windows 10 operating system, in the kernel of Windows 10 operating system, Microsoft has done changes, and after Windows 10 onwards, not all the version of 10, Windows 10 home version does not support. You need Windows 10 professional version or enterprise version or education version. If you are using Windows 10 home version, then you have to install VirtualBox, then Linux virtual machine, and then only you can go ahead, otherwise not. So kind of Linux machine only, not Windows machine. But from Windows 10 enterprise version onwards, yes, it is supported very well. You can create native containers in Windows 10 for sure. There is no problem. And how can we achieve performance requirement using Docker for application that requires more CPU cycles? I am not clear about this question. This question is asked by Sada. I'm not understanding the context of this question. Maybe you can ask your question later. Okay, guys, let me now go ahead.
Okay.
You can take your question later, no problem, guys. Just give me time. You can understand we have around 125 people, so only question, the entire time will go. So pardon me for that. Let me complete my work first. Okay, this is the architecture, but I will make you understand this architecture a little later. So now let me go ahead and let me explain you what things and what all things you basically require to work with. So if you see this architecture wise, you will need a client in your machine to use, and then you will need a Docker host. So actually you will need two machines. Forget about registry, guys. Registry you just can ignore right now in this diagram, right now in this architecture. So in this architecture, the only thing which you can see is that as a developer, as a user, if you want to use Docker on your machine, whatever you are using, maybe you are using Windows machine, Linux machine, Mac machine, you have to install a software called Docker client, and on the same machine or on a different machine, you can install another software called Docker machine software actually, or Docker machine software, in the sense that that system is known as Docker host software. So Docker host is the software which is actually hosting your Docker machine software, which is capable of creating containers, deleting containers, building containers, renaming containers, listing containers, uploading containers, downloading containers, integrating containers, executing containers. So that Docker host machine is the one which is capable of doing that. So client machine, just like you have your machine and there is a client software installed, and from that client software through telnet or through some TCP connectivity or some TTY connectivity from client machine to that server machine or to that machine, what you call generally Docker host, you can run, you can basically execute your commands, and those commands will finally execute on your host machine on which you have already set up your Docker machine software. So you need to have Docker client and Docker machine software. I will explain you Docker registry after some time. Just take it away from this diagram for the time being. So let me now go ahead and let me basically give you basic, working knowledge about Docker, so that if I teach you a lot of theory, that will not be quite good, because we already have a webinar. I have to give you some example also, so that purpose of the webinar is met. Let me give you some example also, so that you can just understand the perspective of working with Docker. So guys, what I'm going to do is, I will come back to this architecture diagram later. I'll come back to this. But before I give you practical environment, I just want to make sure that you understand these concepts. And someone was asking me, what is a Docker container? So if you talk about these, so guys, if you want to work with Docker, so you should be well versed with these concepts. You should be understanding what these concepts are. These are Docker concepts. In Docker concept, the first concept is Docker engine. So what is Docker engine? It is nothing but Docker runtime actually. The main Docker runtime. That Docker runtime which provide you tooling from where you can, using that tooling, you can create container, create images, create build and more things. What is image? What is an image? What is a container? In next half an hour, things will be clear. Image and container and everything. And what is a build? What is image? What is container? Don't worry. Next half an hour, things will be clear. So it is just a runtime environment or a tooling which you will be requiring. Just like for example, if you are a Java developer, you want to work in Java. Why I'm taking example of Java? There is nothing to do with Java, but still, because most of the people nowadays and developers nowadays know Java, so it is easy to correlate. But there is nothing to do with that guy. Don't get confused why trainer is talking about Java only. Just to correlate with that. So like in Java, if you want to work with Java, you need to install Java Development Kit. You need to install some editor like Eclipse, like NetBeans, like Vasart, like RAD, like IntelliJ IDEA. So that IDE, that Java Development Kit is providing you tooling. Using that tooling, you can create your classes, you can compile your classes, you can run your classes, you can package your classes as VARs or RARs. That is what is Docker engine, is nothing but a software which actually you need to install on the machine on which you want to run Docker containers. Not only run Docker containers, you want to create containers, you want to delete containers. That is what is that Docker engine, is the main software which is open source software provided by the organization which is taking care of Docker infrastructure, which is Docker Inc. only. Docker Inc. is the company which is behind this particular Docker environment or Docker infrastructure. And Docker client, I don't have to explain you. In your developer machine, you need to have some software in your system, so that through that software you can talk to Docker engine machine, and then you can do a lot of activities like creation, container creation, deletion, creation images or building images and all that. So client software is required. For example, today you want to work with Git. So if you want to work with Git, you definitely have to install Git client software in your Windows or Linux machine. Otherwise, you cannot push anything, cannot pull anything from GitHub. So that is a CLI software which need to be there in your machine before you can push or pull anything on GitHub. So that kind of software we have for Docker client. It has to be on every developer machine who are developing and deploying using Docker containers. But Docker engine can be only on one machine on which you want to run Docker containers. And they both can be on same physical machine. They both can be on separate physical machine also. Client software can be on separate physical machine, and engine software can be on separate physical machine. But they can be on same machine, there is no problem. What is Docker daemon? As the name suggests, Docker daemon is the main process. When Docker client will send the command, they will actually be sent to daemon. Daemon is a part of engine actually. Engine is software, but what is that runtime process which can take those commands and which consider and entertain those commands? That process is nothing but a daemon process. So make sure a daemon process is running 24/7. Daemon process is just like your web server. For example, you start a web server. If your web server is not running 24/7, because you see, installing Docker engine is no benefit if your daemon process is not running. So daemon is nothing but just like a web server. If web server is not running, you cannot hit from web browser. Web browser will send a request to some IP and 5,000 or 8,000 or 7,000 port number, but there is no web server process running. There is no web server daemon thread running. So definitely when web server is not running, browser cannot communicate with that. So that is what is Docker daemon. So all the commands which are sent by client, actually they come to daemon, and that will execute all those commands sent by the Docker client. Those commands are nothing but, you will understand, those commands are for building images, creating images, deleting images, querying images, inspecting images, history of images, creating container, stopping container, restarting container. Those commands I'm talking about. You see, it's quite easy. Just like you work in database, every database you first start as a database as a Windows service or Linux service, then only you can use then only you can use that SQL command, SQL CLI command line tool to run your SQL command like select, insert, query. You run in CLI tool of SQL databases, and from that CLI to all the queries are sent to the running database server running on 1521 port number 3306. So same we have Docker client and same we have Docker daemon. So Docker client is just like MySQL client to work with databases, and Docker daemon is just like your database server running as a Windows service or Linux service 24/7, listening on port number 1521333006 like that on. Now, Docker file. So guys, this is important. What is Docker file? So Docker file is nothing but the program. So basically, when you work in Docker environment, you have to write some programs. Like in Java, you have to write programs. Those programs are .java files. In C++, those programs are .cpp files. In Groovy files. In Scala files. And every program always contains instructions. .java file contains instructions for Java virtual machine or Java compiler. Same C++ program. So same different programs have instructions. So here, Docker file will contain the instructions. So we call it a program actually. So you have to write a program in Docker, and that program will have instructions, and those instructions will decide that your container has to execute what all commands one container will actually execute. So that is nothing but a program file which you will create. And the program file will have some instructions. I'll show you the format of the instructions, and I will show you what kind of instructions we will have. Definitely it is not a program file. It is not just like Java programming language, C++ programming language. It is actually a text file, and this text file will help you to contain your commands, and those commands are going to become instructions. So while your containers, how containers will be built and how containers will be run, and what all containers will have, what code they will have, what dependencies they will have, what jar, var, rars, or what database, or what JDK, or what Tomcat, or what C++ environment, JavaScript environment they will have. Because here Docker is not limited to Java, it is for any kind of language, any kind of environment, any kind of database. Then what is a Docker image, guys? Docker image is the one which you will be creating from this program file, which is a Docker file. So from Docker file, we will create an image, and that image will help us to create our container. So just forget about union file system right now and volume right now. I will not explain you those things right now. That will be too much in detail. This is a webinar, not a very technical, detailed training on each and every particular concept and sub-concept. But let me just skip them for some time right now. Let me talk about Docker image and Docker container. So guys, Docker image is the one which is built from a Docker file. So Docker file is just a program. When you will execute that program, when you will compile that program, what you will get is an image. After compilation, you will get an image, guys. And once your image is ready, when you will run the image, what you will get is actually a container. So what is a container? Runtime instance of the image is a container. What is an image? A compiled version of the Docker file is an image. What is a Docker file? Is the program in which you will basically do the coding, infrastructure coding, your automation. You will do the coding for automation of the code and environment shipping. Automation has to happen today. You can understand what I'm explaining you for last half an hour, that we have to ship together code and environment together. So that has to be automated, and for that we need to write program somewhere that this program will ship this code with these file structures, with these directories, with these jars, var, rars, and this Tomcat server, this database. So that coding has to happen in a file called Docker file, and we call them instructions. And as per Docker terminology, that there are certain command, like in every language you have to learn certain command. So in Docker you have to learn those commands while creating Docker files. So the only programming you will do in Docker world after installing Docker software is Docker file programming. After that, things are quite done automatically. There is nothing to do, just commands will do their work. The only manual work you will do as a developer will be creating Docker file. Like in Java, you .java file you create, .scala, .groovy, .cpp file you create. Once they are ready, after you compile them, they will be executing as per the instructions you have. So create a Docker file, compile them, you will get an image. After image, when you run the image, which is a compiled version of file, once you run the image will basically run time instance of the image as a container. So when someone was asking what is a container, runtime instance of the container. So guys, if you relate with Java, so you can relate with Java like that. Docker image just like a class file, and Docker container is just like an instance. And in Java or in C++ or in any language, from one file you can produce many instances. For example, if I have a class called employee, I can create 100 and 200 and 1000 of instances of employee class like E1, E2, E3, E4. Similarly, if I have a Docker image built ready, from that image I can create hundreds and thousands of containers. They will all run with the same setup, same configurations, and same things what I have mentioned in my Docker image. So Docker image, just to correlate, guys, just to make your life easy so that you can understand things easily. Docker image just like a Java class, and Docker container is just like an instance. So one Docker image, you can create many Docker instances by in the form of many Docker containers. And to create that image, which is a class file, you need to write a program that is a Docker file actually. So these are some Docker concepts which you should be aware about before we just go ahead. So just a simple hello world example you can see here. So before I go ahead, guys, let me now give you some examples. Enough theory. Let's go a little ahead right now. We'll just have to look at some examples. I will start from this screen where I am right now. I'll come to the infrastructure. So guys, the first things first. Docker installation. Why Docker installation can be done on Linux, Mac, or Windows machines. It means if you can install Docker on any of these machines, it means that you can definitely run and create Docker containers on Linux and Mac and Windows machines. Today Windows also supports, I told you, particular version of Windows, and there is a native support, guys. So it means you can install Docker software on Linux as well as Mac as well as Windows. Any one of them, you are absolutely free to do that. So if you are using Linux, it will depend upon which flavor of Linux you are using. Let's say you are using Ubuntu, so you can use apt-get, which is a package manager. You can use yum package manager, apt-get package manager, or you can download a pkg version. Like on Linux, there is a pkg download available. So let me just take you to the download section right now. Docker download. If I take you to Docker download, so Docker is available for everything today. This is the official image. Docker is open source, guys. We don't have to worry about it. So you can see if you want to download Docker, so we have Docker desktop software available for Windows as well as for Mac, as well as for Linux also. And for Linux, we have even PKG version also downloadable. And let me go to the Docker download page. Actually, that will be better. Download page will be Docker download, main Docker download page. Docker download. Get Docker. You can see main page, Docker desktop for Mac, desktop for Windows, and Docker for Linux. We have it available, so you can just click corresponding here, and then you will get it. For Windows, I told you minimum requirement. You should have what minimum requirement? Windows 10 Home Edition will not do. Enterprise Edition or Professional Edition. Mac, fine. Linux, download PKG version. You can see which all Linux flavors are supported. That Docker is available as DB files, and I told you already that for this webinar to make successful, you should have some knowledge about Linux operating system. So you can download as dev.yl file or RPM files or PKG file also. But if you're using some package manager like yum, like apt-get, directly you can run from within your terminal window of Linux flavor, whatever you are using. There is no need to download dev file or RPM file also. So guys, as you can see, I am right now using Windows machine, so definitely I will be downloading for Windows only. Docker Desktop for Windows. But remember, Docker Desktop for Windows, if you download, you have to first check whether you have. I have Windows operating system. So I'm checking in my operating system, Windows operating system, which flavor I have. See, I have Windows 10 Home flavor. And on Home flavor, you cannot download Docker for Home flavor. Make sure you should have Windows 10 Enterprise Edition or Professional Edition or Education Edition. But I have a Home Edition, so I cannot download for Windows. But guys, for Windows Home flavor or Windows 8 flavor, there is separate download. I will tell you which one you can just grab. Functionality wise, they are all same. There is no problem. So you can download this for your platform. If you have a home version of Windows, there is a special download for this one, Docker Toolbox. You can download. That's a software for those flavors of Windows on which we do not have that Windows desktop, or Docker desktop and Docker desktop for Windows support is not there. You can download this one. You can download from here this Docker Toolbox. Simply go to this link and download the latest one, which is 19 version. You can just download this 19 version from here. Simply download this one, Docker Toolbox. That is the only software you will require. So after downloading, simply you don't need a trainer help. Simply download and install it. And guys, in my system it is already there, so I can switch this. So I'm going for Windows flavor of this. Docker Toolbox of Windows. All I need to say the Windows 10 little old, or Docker Desktop or Windows Pro Enterprise and Education flavor. And definitely we have Docker for Linux. But after installation is done, then there is no difference. They are all same. It is only installation difference, which particular download you need for which operating system installation. But after that, they are all same. So guys, I have already got it. So because I have Home Edition, the Windows 10 Home Edition, so I'm just going to that Windows Toolbox. Let me show you. I will not waste time downloading it. I already have it. It's in my system. I should have Docker here. I think it should be in downloads. Yeah, I have it. You can see, guys, on my desktop, you can see this is the one Docker Toolbox 19 version .exe. One single kit is enough. So this kit is having so many things inside. This kit is actually having inside a virtual box. On top of that, there is a Ubuntu Linux flavor installed. Within that, Docker engine is installed. Docker client is also installed, and Docker GUI client is also installed. CUI client and Docker GUI client is also available. In the single download, so many things are there. So when you run the installer, it will ask you a few questions, and just simply say next, next, next. You don't need anybody's help. I don't want to show installation. Installation is already done. So that after the installation is done, you can just run Docker CLI tool. But there is no benefit to run Docker CLI until Docker ka Daemon process is running. So make sure Docker Daemon process is running. So I want to show you first, after installing it, where it is in my system. If you see Docker Toolbox, you can see I've already got Docker machine. That is what I was talking about. So Docker machine is the one what is actually required for your Docker host machine. And this is your Docker CLI tool, guys. I told you this single download has everything. Docker.exe is the Docker CLI client command line tool, client side tool, which you will be using to shoot up all the command which will go to Docker Daemon, which is a part of Docker machine. So we have this Docker machine, we have the client side tool already here. So we have both of them. And Docker comes with a lot of other things like Docker, we call it Docker ecosystem. Like we have Docker Compose, we have Docker Swarm, we have Docker Network, we have, there is a ecosystem of Docker that is beyond the scope of this session, so let me not talk about that. Docker Compose, Docker Swarm, Docker Network, so many things. So we have Docker CLI already there, docker.exe, and we have Docker machine. Inside that, we already have our Docker, what I was talking about, Daemon, which will be running, and this CLI has been configured in such a way so that it will always connect to the locally running Docker daemon to execute any commands. So guys, let me now, after installation is done, let me now start Docker servers. After installation is done, guys, on the desktop you will get this icon here. From here you can just start it. It is nothing just a simple.
Please plug your charger.
Please plug.
It is a Linux bash command, bash terminal window, from where you will be able to execute all the Linux-like commands. From this command window, they will go to Docker daemon, which is a part of the Docker machine.
Sorry to interrupt you. Please plug your charger. Your low battery.
Yeah, just give me a minute. So it may take a little bit time while starting it, because trying to grab the IP address for this this Docker machine, which is running on top of physical machine. See, you can read this line: setting Docker configuration on the remote daemon. Definitely. So now, guys, you have got your Linux terminal window from where you can shoot up all the commands. So don't think that any longer you are in Windows operating system. You're actually a Linux developer now. So Linux knowledge would be required. So you can see Docker is configured to use default machine with IP. Guys, we have to remember this IP address: 192.168.99 and 100. So whenever you want to talk to a Docker container on this machine, whatever is the physical IP address of this machine does not matter. That will not matter at all. We have to use this IP to talk to Docker container from any other place in the network, if this machine is a network, or maybe from the local machine itself to talk to the Docker container. This IP address is given to this Docker container. You can see a whale is there. On that whale, there are small containers. So in this terminal window, now I can just start working. Now, what I want to do first, there are multiple ways in which I can teach you. Guys, one thing I can teach you is, first of all, I can okay, let me just do that way. It will be easy for you guys also to go ahead. Let me help you how to create your own container. Let me not use ready-made container. There are already ready-made images and containers many. So let me help you how to create your own container, guys. So if you want to create your own container, so all the commands you have to just set up run from here. But make sure you cannot create a container without image, and image cannot be built if there is no program file or if there is no Docker file. So let me first create a Docker file. I will be running from here. First, I want to check whether Docker has been installed properly or not. And we have already seen we had a executable called docker.exe, and that docker.exe I'm able to run from here. Docker command, this is a CLI command I'm able to run from here. So all the CLI commands which will be shooting up from here for your Docker daemon, they will be run with a command line tool called Docker only. So let me just check which version of Docker I'm running. So it's telling me Docker version I'm running is 19.3. That's fine. And you can see right now, this is the Docker client version, but it's this command also telling you by talking to the Docker engine, it's saying Docker engine server edition is community. So you can see there are two editions of Docker engine comes. When download from there, you will see there are two editions, Docker engine community edition and Docker server enterprise edition. So Docker engine community edition is there, which is actually free. Enterprise edition is not free. So that is a proof that one single command has proved that Docker CLI is able to communicate to Docker server, telling you Docker server version as well as Docker CLI tool version both. Now, we have to build a container. We have to build a container. Before that, we have to build an image. And to build an image, guys, we have a command called build. But there is no benefit to run this command because this command will ask you where is the program file. Just like Java C compiler, you don't have Java C compiler. If there is no file available, then there is no benefit of running Java C compiler. So we need to write a program file first. What I will do, guys, is I will first check in which directory I am in. My working directory C program files Docker toolbox. Okay, so what I'll do is let me say back. Let me say pwd. I'm in C drive right now. Okay, what I'll do is, because right now my system is being shared between Linux machine and system machine, so what I'll do in C drive, I'll just create something like, I'm creating a folder called examples. I'm creating a folder called examples right now. In this examples folder, let me write my very first program in Docker file. But guys, before you write your program in Docker file, you need to understand a little bit about Docker file first. So guys, when you write a program in Docker file, so first of all, Docker file is actually a Docker file. Docker file is just a text file. In Docker file, the programming will be done just not like a programming. So Docker technology has given you some bunch of headers, some bunch of instructions which you need to mention there. Some of the instructions that you can write in Docker file is from, I'm writing in capital letter, that is not mandatory. Copy, add, working directory, cmd, run, entry point, expose, just some of them only I'm writing, label, some of them, etc., like this. So like when you learn any technology for the first time, you will encounter some new things. Like some other day you started working with C++, Java, you learn some new things like interfaces, classes, inheritance, extend keyword, or interface keyword, or implement keyword, like that only. Similarly, when you will work with the Docker technology, the very first thing which you need to do is creating a Docker file. The very first thing. If you know how to create a Docker file, then definitely you are fit for Docker. When you will start writing the code in Docker file, code is not just like a programming code. So actually you have to write code in terms of instructions. So this Docker file will have instructions, and those instructions will actually make sure how your image will be built from. So the most important instruction is from instruction. From instruction is used to mention base image. This is very important, guys. Very important. Mandatory. Which is mandatory? Mandatory, guys. From instruction. Any image you will be creating in Docker, any image has to be always created from another image always. So that another image will be known as a base image, and then you will be creating your own image. So base image is just like I'm just correlating with Java. Just like in Java, you create class A which extend from class B. So class A extending class B, and for example, inheritance is happening here. Image A inheriting from image B, inheritance is happening, and that is the beauty here, guys. That's why containers are lightweight here. So always choose a base image. On top of that, start creating your further image. So that's why the very first instruction should be from, which will be mentioning a base image. But the question is where this base image will come from. So guys, where this base image will come from is This is exactly where Docker Hub comes into the picture. What is Docker Hub? Docker Hub is the cloud setup by Docker team, cloud URL setup by Docker team, where Docker developers meet. Is the cloud URL set up by Docker team where Docker developers share their work to each other. Is the cloud URL where Docker developers create container repositories, where Docker developers set up permissions for containers. So guys, Docker Hub. So it is a cloud URL. This is a cloud URL has been set up by the Docker team, only for all these purposes. So nothing is special. Just like GitHub. When you want to share your code through Git, you will upload in GitHub and someone will download from GitHub. When you want to share an Android application, you will upload on Google Play Store and someone will download from Google Play Store. When you want to share some code, you will upload on sourceforce.net, someone will download from there. Just like that, it is a platform for Docker developers to work together. One developer will upload the container, other developer will download the container. It is just a Docker, we call it Docker Hub, where developers meet, and actually it's a cloud, we call it Docker Cloud actually. So when I say that in the Docker file, the very first instruction will be from, so this is where you will mention base image. So what base image? That base image will be one of them which has already been available on Docker Hub, and that Docker, how that image came there, that image might have been uploaded by Docker community itself, or by one of you, or any one of us might have uploaded that image, which I will make my base image. So make sure when basically building your Docker, when building an image from Docker file, make sure you have a good internet speed, good connection speed, because when Docker file will be built, it will download that base image, maybe size is 20 MB, 30 MB, 40 MB, 100 MB from Docker Hub into a local machine. And after that, only these further instructions will be add on top of that base image. And that is why when you talk about a Docker image, Docker image is based on layered architecture. It is based on layered architecture. Docker image is always add on top of base image. Docker image is like a onion layer. In onion we have layer over layer. So every image, even that image which you call a base image, that image is also created from some other image. Any single activity you will do on top of an image, that will add a new layer in that image. So that's why Docker, if you talk about Docker, so Docker actually is Docker images are based on just like a we have onion, that onion inside onion, if you see, where there is a very small kernel environment, that particular what I talk about, there is a small in the middle portion of the onion, we have a particular small portion of that onion available. On top of that, we have layer 1, then on top of that layer 2, then on top of that layer 3. That is the architecture of onion. So actually this Docker technology has been inspired by the onion layer only. Any activity you will do in on top of base image, that will add one more layer, and that becomes another image which other guys will use. They will add more layer, that will become another image. So every image is nothing but combined together, many layer become an image actually. That's what I'm going to tell you. For example, I downloaded an image. In that image, I copied 2 WAR file, 1 jar file. I copied 1 directory. Anything I'm copying, I'm adding a new layer. So then when finally I will create a container, that container will be all the layer of base image plus extra layer I added, and that is how container will be created. And that is the beauty here. Anytime we can remove layer, anytime we can add layer. So it is nothing but based on inheritance architecture only. That is not true in case of virtual machine technology. When you use virtual machine technology like VirtualBox, like VMware, like Parallels, this is not true there. This is another beauty here. Each image is always adding extra layer on top of base image, and that is how the next containers would be created. So you never have to start from the scratch, and that is going to be the benefit, guys. Always start from Dockerfile. So we have a copy command to copy from source host to destination host, which is Linux mostly. Copy commands used for that purpose. Files and directories from source host to the destination host, which is Linux mostly. Add also for the same purpose, but add has some advantage over copy. Working directory to change to command to change to a particular file or directory. Guys, these instructions are nothing very complicated, very tricky to understand. Don't you think you do every day copy operation every day? And you want to add some more file into a directory. You want to change to the working directory or B or C. You want to run some commands. It's easy to understand this technology. That's what I was talking about. It picked up well. Like that only. So just few commands. I told you there are many more commands. Like we have volume command is there to set a volume. We have link command also there to set up a link between two containers. There are many more commands. Just I'm giving you some of the command as per this workshop, as per this webinar we have. So now, after understanding a little bit, let us create a what do you call a very simple container. Before container, let me create a image, and I can't create image if my program is not ready. Let me create Docker file first, considering all these things in mind. So this is my working directory in which I will write my program. So let me first create a new Docker file. Most probably this file, the name will start with capital. Name will be like this. There won't be any extension, but you are free to change the name of this program file. If you change the name of the file, then you have to give a particular command line, command prompt argument while using this Docker file. So in this Docker file, let me have some instructions. So the very first instruction which I will have is from. Then I will have some instruction like copy. And like I will have some instruction like cmd, like that only, just nothing else. So very simple. From, copy, command, from instruction. We'll ask you base image name. The question is, which base image? Guys, this is where you have to search Docker Hub. What all images are there already? What all containers are already uploaded on Docker Hub, which is a cloud for Docker, just like you do on the GitHub or SourceForge or Google Cloud, or you say this Android Play Store. Before downloading anything, you always search in Android Play Store. You download app, you download this game or that app or this app, then only you download, like always we do. So now let me take you to cloud.docker.com. It will automatically redirect you to the right URL, cloud.docker.com. That's the cloud URL, hub.docker.com. So guys, when you come here, it will definitely ask you to log in. I have already logged in. Actually, I have my profile here, like in GitHub and all that. I have my profile, so I can log out. But very first thing, when you will enter here, it will ask you to log in if you have an account, or you can create a new account by doing sign up. Choice is yours, but let me not get into that part. Let me log out. Okay. So right now I'm not logged in. This is the very first UI you will have. This is a Docker Hub. So you can just search here for available containers which have been uploaded by a lot of other guys in the past, or maybe officially by Docker community only. Let's say, for example, my planning is to create a container in which I want to use MySQL database. Let me see if there is a container which is matching with the name MySQL. Let me just search. See guys, I got one. I was trying to search in this Docker Hub. It's saying MySQL is widely used open source relational database management system. So guys, we got one container. We have found it. And see, a lot of other things are given about it. Document reference, supported tags, and respective Docker file link, because this container itself built using a Docker file. If you want to get into that Docker file, some quick references are given and some help pages given, like that only. So if you want to go through them, you can, but there is no benefit right now. Let's say I want to create a container tomorrow for DB2 database. Let's say, is there one available? Yeah, guys, we have available IBM DB2 warehouse, IBM DB2 developer edition we have got. By IBM only it is uploaded. Let me see if there is a container which already has Oracle database installed inside. Yeah, I got it one. It is, see, officially it is done by Oracle only, uploaded 3 years ago, and it contains Oracle database to LC Enterprise Admin. See the benefit? Why should I download and purchase Oracle database server and install it and then ask a DBA to do configuration of schema and all that stuff and port number? Why not to download container already which has a database server installed inside, and why not to use it out of the box and it is shareable? Let's say I have a JavaScript guy. Let me use for Node.js container if I have. Yes, we got one. Docker image for Node.js. This is the one. Docker image for Node.js. 4 years ago it is uploaded. See, why should I download Node.js individually and install in my system? Let's say I'm a developer for Scala language. Is there a container already having Scala language inside? Is Scala container? If we have, we'll just come to know. I'm sure in the list you will get one, because I can see so many Scala things, and you will get for sure. Similarly, you can check for Java also. If there is one for Java, you can just check. Yeah, we got for Java, OpenJDK we got. And reference is also given. Start Java instance in your app, like that only. So let me just take it from here. Let me copy this only. And guys, remember, yeah, let me just close this Docker Hub. That. Guys, remember, I'm right now considering that you have little bit knowledge of Java. There is no intention behind Java, but at least I have to show you one example. So from the perspective of this example, considering the fact that whatever number of people have joined today, most of them are aware about Java. So considering that fact, I'm giving an example of Java-based container. So from Java-based container I'm creating. So let me create a container for Java version 8. Guys, when you use from command, it will ask you that image ka name, from which image you want to use as a base image. So make sure there is an image within a base image called Java available on Docker Hub. That hub.docker.com, search for it, and that image, every image uploaded there, and that image will be tagged with a version number or with a name. That every image is always tagged. That tag can be version number, that tag can be alphanumeric name, or that tag can be alphabetic name only itself, value itself. So from, I'm saying I want to build a new image from an image whose name is Java and which is tagged as version 8. See guys, I'm not sure whether it is there or not, but if you want to make sure it is there, I have a suggestion for you. Before you make your hands dirty and you just make a mistake, I have one suggestion for you. One way of searching it from here. Okay, close the browser. That search toolbox in that search text field in which I was searching. Or if you don't want to search from there, you can search from here also. You can search from Docker search command, and let me search for image. Is there an image called Java on the Docker Hub? If there is an image called Java or any number of images found with the matching, they all will be listed. See, so many found. So many found. The same thing can be searched through that Git, that Docker Hub URL also. So many guys you found with the name Java. You can see there is with the name OpenJDK, Java, so many. Java is content class based. We have got an image found and many found. So we have got image Java. Even you can say which image has how many stars, official or not. Official means they're officially uploaded by the Docker community only. So many images have been found. So let me create my image based on base image called Java. Now let me copy from my current folder, copy command. I told you already about copy command, guys. Let me copy from my current folder. I have a file. I will create a file. Just wait. I will create a file. Let's say called travelservice.java, and I will copy in USR Java folder. Guys, this is important. What I'm just trying to do here, copy this .java file to this destination folder USR. Guys, I told you, you must have knowledge about Linux operating system. So in Linux operating system, you can see the root always start with /. There is no C drive, D drive. In under root, we have a folder called USR. Under USR, I'm expecting a folder Java. If it is not there, it will be created. There is no problem. If there is no folder is there, it will automatically created. But what I'm telling you is, you have to be very careful. The source operating system from where your copy is which one, and the destination operating system is which one. So I know my destination operating system is Linux. The question is, how do I know that? So guys, the answer is very simple. I'm creating my image from Java image, and I will show you the history of Java image. That image actually was built from Linux image. So Java image, if you use that Java image, already has been built from a base image called Linux, I think Ubuntu flavor, or I think CentOS flavor. I will just check CentOS or Ubuntu flavor. So already in that container, there are CentOS directory structure available. CentOS or Ubuntu directory structure is there, which is a Linux directory structure is there. So Linux directory structure, there Java already installed, because I'm creating from Java image, Java already installed. So the container I will get, that container already have full file system of Linux. That container already has Java 8 installed, and the container already has root folder start with this. Under USR folder, I'm expecting a folder to be Java. If not there, it will be created. And what I'm doing is, from my current working directory in my source operating system, I'm copying this file, whatever it is, I don't know what it will do. This will be copied into this particular location. That is what I'm doing right now. And if you see right now here, this is my working directory. If I go ahead, this is my working directory. I'm in C drive. Let me move to examples. And let me say ls. Yeah, see, this is where I'm working. If you say pwd, I'm in C examples. That is my current working directory where I will build my image. So this will become my current working directory. And in this from this current working directory, I'm copying this .java file to the inside container. We have this directory structure. So you have to keep these things in mind because you're working with two operating systems at the same time. Source OS, destination OS. From source, you are moving things in destination container, which is based on some operating system. File system. Operating system will not be there, but operating system ka file system will be there. Operating system is always installed on the physical machine. That is not our worry, but that file system is there as a layer. In that file system, what do you want to copy? That is what we are copying right now in this image. Then what I'm doing is I'm saying cd dot cd that folder. So work directory is another instruction. What the instruction will do, in that inside the container, your current working directory will become this one. This is where exactly we will say, generally we say cd like that. So this command is just like cd. Then another instruction is run. With the run instruction, I can run any executable, for example, javac executable, notepad.exe, wordpad.exe, any executable which are inside the underlying target image or target operating system or target container, whatever commands are there, we have. And definitely we are already creating our image from Java image. So there we already have javac compiler. There we already have java.exe interpreter is there, compiler is there, because I'm building my image from Java image, which is built on top of Fedora or Linux, this Ubuntu flavor. So make sure, guys, you have Linux knowledge. Otherwise, I'm helpless. I can't help you here if you don't know Linux anything about that. So make this working directory, run javac, and then what I'll compile is this file. I will compile. Javac will compile. Why this javac will be able to compile? See, what is the working directory today? Before running this command called javac, your working directory is this one, and in this working directory you already copied this .java. So javac compiler will run and will compile it under this folder. So javac is actually you are running javac command under this folder. So this is the first time you are encountering maybe Docker file or these kind of instructions. Maybe a little tricky for you to understand, but once you create one image, two image, three image, I'm sure about it. These things are very easy to understand and you will become used to them. Run instruction is there, and finally, guys, cmd instruction is there. Cmd instruction is your entry point. When developers will be downloading your image and they will be running container from the image, this is the default command which container will run when container starts actually, and that is what I'm doing. So cmd will ask you, the first argument to cmd instruction is executable, any executable, java.exe, browser.exe, explorer.exe, chrome.exe, wordpad.exe, or any executable of Linux, whatever number of executables or cmd or sh files you have. The first argument is executable, and after that param1, param2, param3, param4, param, they will all become parameter to this particular executable, whatever you have, because my executable is Java. And Java executable ka first parameter should always be the program name to execute. That is my program name called Java travel service.class, which will be compiled by the time I reach this particular instruction in the file. So total number of instruction in my Docker file, I have only 5. And remember, guys, I'm doing it for simplicity purposes. Otherwise, there are many varieties of ways I can teach you how to create your own Docker file. I can create Docker file from a MySQL image, nothing to do with Java and all that stuff. I can create a Docker file from another image called Ubuntu image or some other image, and there is nothing to do with Java itself. But I am just going by Java because I want to give you a practical example right now. So guys, Docker file is ready. Close this Docker file, but make sure you should have travel service.java along with it. So Docker file is ready. Let me have some simple program here. You can have Java file or anything, means anything, any PPT file, any PDF file, anything you want, you can have. Because image, that is what we call image. Image is nothing but the combination of file system and these instructions become an image. Any files, any file system you want to copy and these instructions combined together make up an image. That is actually what is an image. Let me just create it, and I'll do very simple operation here. Public static void main. Very simple operation I'm doing here. All right. Just an ordinary simple Java file, nothing else. .java file, no compilation, nothing. So guys, in this folder I have my Docker file and my Java. The files I want to copy inside an image, they are available. They can be here, they can be anywhere. And my program file is also ready. This is my program file right now, as you can see. You might have understood a little bit. So the image, base image, what to copy, from where to copy, and where to copy. I'm considering that the target operating system is Linux file system. Then cd that one. Then run javac into this folder wherein we have .java, which will be compiled and will be kept there only after compilation. Then I'm going to run Java. Remember, this any commands you give here, any executables you give here against CMD, they become entry point. They only execute when container starts, but they execute, all of them execute when image is being built. That is the difference. If you ask me the difference in run and CMD, run, workdir, copy, they all will execute all the instructions when image is being built. But this last instruction will execute, CMD instruction will execute only when container is started. All right, I'm done. Instructions are there. This file should move inside the container, file system, USR, folder, and Java folder. Now, guys, if I go here, and if I say pwd, my print working directory is C examples. If I say ls, these are the files, Docker file and travel service.java. So guys, time has come to build an image. So guys, step number one. If you talk about steps, step number one, create a Docker file which will have instructions for building a new image from the instructions. Number two, create a new image using build command. Let me do that now. Let me get an image using build command. So guys, time has come to, so make sure you have to remember, you have to just take care of certain things. The very first thing you take care of is where you are standing. That one, check Docker values are not, because when you will be creating, building an image, always in the current folder, Docker will look for a very special instruction file whose name must be Docker file only. If you change, you can, no problem, but then you have to mention that. Let me use Docker and build a command. And while using Docker build command, it will ask you that image which you want to build, what should be the name of the image. So give the name to the image, tag name. -t means tag name. Every image should have a tag name, means should have a name, whatever tag name. Let's say I'm creating an image, whatever image you want to create it, whatever name you want to give it, let's say travel. Every image should have a name, and definitely image name is travel, and what version of the image. So image name, travel, and version of the image, let's say 1.0, 2.0, whatever. Fine. Build a new image with the tag name travel, and let me tag that image with a version number called 1.0. Image name and tag name. But where is the Docker file to read the instructions from to build this image? So build command will always ask you for Docker file. And guys, see what am I doing today? I'm giving dot. Why dot? in the current folder where I'm standing right now, already Docker file is there with a fixed name called D capital Docker file. Build command will look for that and then will basically start creating an image. Enter. And remember, the very first instruction was to have create this image from a Java image. What if the Java image has not been downloaded till now? So guys, this build command will automatically download Java image first from Docker Hub before you start building your image. And if that image already there, then that image will not be downloaded. So time would be saved, just like Maven jar file only. In Maven also, jar files are not downloaded if they're in local central repository. I have downloaded already because I keep working with the Docker, so I might have in my system. Let me enter this command. Let's see the instructions or commands. You see, guys, it is telling you something. It is telling you the very first info coming is sending build context to Docker daemon. See, the command you're running is Docker, but this command is client only. It is not capable of doing anything. So these all commands, build command, and all the commands are sent to Docker daemon, which is already running. Then Docker daemon, each and every instruction was sent there. See, the very first instruction was sent. Total instructions were step 1 of 5, 2 of 5, 3 of 5. You can see 1 of 5, 2 of 5, 3 of 5. What is that? Something is wrong. Wait. On Java. In that image, it's saying that mkdir user is not a directory. It should create, actually. We don't need to, because if the directory doesn't exist, it's always created. We don't have to take that pain. But if it is asking us to do that pain, we have no problem at all. We have one more instruction called mkdir. In the target system, you will create USR and Java. That is not there. So these instructions, you will have the detail of these Docker file instructions on Docker, the Docker documentation already. Let me build it again. mkdir or make dir. It should be make dir because we'll just check because these headers not easy to remember. You have to just make sure that you remember the header name properly. Make dir. Okay, just let me check the reference of the old example, which will not take much time. Let me just check that. Yeah, same thing we're doing here. No, so we have the same thing. OP travel service into user Java. User Java, working directory Java only. Yeah, correct. Same thing I was doing actually. We go ahead. It should not complain at all. Once the local file is ready, let me build the image. Building. Okay, got it. There was a small problem in the copy command. In copy command, if you might have seen earlier, the small problem we had was this one only. That I was trying to copy a particular file, and for that the expectation was the directory exists. But when you say dot current working directory, everything will be copied, and any subdirectory which are not there, they will be actually automatically created. Because we are trying to copy now files and directories both. Earlier I was just trying to copy only files. The directory expected directory should be there. Okay, that is not a big problem. So just see, guys, if you are first time user of this image, I want to show you these instructions. Sending the build context command to Daemon done is step 1 of 5. How build command came to know is step 1 of 5, 2 of 5, 3 of 5, because the total number of instructions you can see in your system, in your Docker file are 5. First instruction is create this current image from this Java image. If not available, download it. So guys, it is not downloading Java image with tag number 8. It is already downloaded. Let me tell you and I'll show you. That's why it is not down. Otherwise, it will show you downloading, just like Maven Central Repository. It is not showing because in my system it is already downloaded in some other execution which I did earlier. Then second instruction, copy every file from current working directory to USR Java, done. Then make that USR Java working directory, done. Then run Java C on that travel service.java, done, no complaint. And then CMD, and CMD will not execute, but this instruction will be sent in the inside the image which is created, done. And successfully built image. So guys, when an image is built, every image is given a unique identifier. This is the image identifier. Automatically it will be decided by the Docker engine. That is a unique identifier given to each every image, and that image has been tagged with a name called travel 1.0. So guys, you have image with this name and you have image with this ID. So image is ready. How do I know image is ready? Remember that this is not a container. This is just an image. Image is just like a Java class. From this Java class, from this image, you can create container 1, container 2, container 3, container 4. Container is just like an instance. You can run a lot of container with different varieties of parameters. Image is ready. How do I know whether image is ready or not? So guys, we have a command Docker images will list you all the images, whatever are there in your system right now. So if you see in the system right now, the number of images are many. See, every image has a name 1, 2, 3, 4, 5, 6. So many image names, their tag versions. Every image should have an image ID. Created how much time back, 2 minutes ago, 5 minutes, 7 hours ago, 7 days ago, 20 months ago, 3 years ago, like that. And then image ka size. See guys, if you look at this, repository means image name, image ka tag name. Every image has a unique identifier. It is created when, and see the size. You will be wondering why 643 MB. So guys, it is built from Java image, and Java was built from some Linux image. Hardly what I copied only. One dot Java I copied into this particular image, which is a container image. Why size is 643? That is the reason size is 643 basically, because Java image is built from some other image that is built from some other image. There is a file system also, Linux file system ke all files, kernel file, base file needed are there. That's why the size is going to be around like that only. So image is ready, but guys, there is no container existing right now. Let me teach you how to create a container out. But we have got an image right now. This container image is there. So guys, if you want to know create a container, it's very simple. After image is ready, then create a container using Docker create. We have a command called Docker create. We'll ask you image name. That's all about. It will create a new container for you. Enter. Sorry. When you give, it will not work, guys. It will fail. When you give your image name to create a container, you have to give fully qualified name, image name and tag name both. If you don't give tag name, it always looks for latest. But where? Locally. That is very important. Unable to find image tag name with the name image travel : latest locally. And now searching on that one, what do you call? It's searching on this what I told you. This cloud URL, which is the Docker hub URL, not found locally, not found there. So if you forget about the tag name, always latest is found locally or globally, which is not available. So it is not creating. So that was my mistake. So let me say image ka fully qualified name is 1.0. Image name for the tag name. Let us create a new container right now. Enter and the new container will be created. See guys, if this command is successful, you will get a container ID. This is a new container ID, which is a hexa value, which is the digest value, hexa value. Container ID has been generated. New container has been created with this complete ID. And every container is given ID as well as a name. Automatic name is given. So let me now check whether container has been created or not. Container is created or not. So guys, we have a container right now. So if you want to know container is created or not, so there is a command called ps which will list all the running containers, only running containers. See, no running container. Every container must have a unique ID from which image it is produced. One container, there can be 20-30 container from same image. Container ka default command, CMD instruction, that becomes the default command of the container. Container is in which this is created when. What is the status of the container? Container status can be created, exited, started, stopped, paused, killed. So many status of the container can be. Container has exposed any internal port to external port or not. And containers are always given some dummy name, random name by the Docker daemon. You can also choose a name, but right now no container is running. This will show you running container detail. But remember guys, this container has been created but not running. So let me now show you all the container whether they are running or not. PS-A. PS means all processes. PS means process. Process means containers. Any container running means running process. All process whether they are running or not. You can see so many containers here. Because I keep creating. Here you can see so many containers there. So guys, if you see in the list, first column is container ID. Every container should have a unique name. See, container is built from which image? Quite obvious, coming on top. And see the container main command. Some other day when the container will start, this will be the main command of the container to run. And that's why within container, see guys, within container we have two things. That is the beauty. Within container we have code, which is travelservice.class, and within container we have JDK environment. That is what we need. So code with environment, both the things are there. And status is created. It has not been bound with any external port. And this is the default random name has been given by Docker. Laughing buck, any name will be given randomly. So guys, we have a container but which is not running right now. About a minute ago it is created. That is status. So it can be created, exited, paused, started, restarted, killed, whatever state. So guys, time has come to run the container after creating it. After seeing yes it is there, let me run the container. So again, run container. For that you need to know container ID, or you need to know container ka default random name, whatever is given. You can ignore them. There are a lot of containers which are already there in my system, already created from same image, many containers created, same image, many containers created. Okay guys, so if you go there, don't forget to copy container ID. I copied here. Now time has come to run the container. So guys, if you want to run the container, it's so simple. If you want to run the container, it's so simple. Just go ahead, Docker, start, and container ID, enter. Container has started, but when container has started, where is the output? Where is the output? Because when container start, that default command, CMD command should execute, and that will run your public static void main. That will print something. That command, so that output is not coming because now I'm saying Docker attach to this running container which I had. Okay, but because the container is, what is that? Docker. Yeah, because the container has been stopped, so I cannot attach to it. I can attach to a container which has already been, which is already running. Only you can attach with that container. So let me do one thing now. Let me again check my container details. Yes. See, no container is running right now. Let me check all the containers. Okay, all the containers are coming. When you start the container, this command will run, and if this command run, it will execute a travelservice.class file, which will has public static void main. It will print something. The question is why it was not printing. So let me tell you guys, there are many ways to do this. There are many answers I have, but let me give you the simple answer. So I want to give you right now. Copy your container. Sorry, not the container ID. Now I want to tell you a shortcut. Shortcut of what? The shortcut of these two commands. The first command was create from this image a new container, and after creating a container, I copied container ID. Then I started using start command. So there are, after creating image, so to create image, build a command. Once image is ready, create is to create a container, start is to start a container. So guys, if you want to create and start together in one command, so there is a command called run. It does both. From this image, it will create a new container with some container ID, as well as will start also. So it is a shortcut command for both the command. Create plus start is equal to run. So if you want to save a little time, you can actually run the container using the run command. Let me do this now. Shortcut command I'm giving you just to run. See guys, that is a proof. When you created a new container, that container was run, and when the container was run, this is the output. Let us just travel and travel and travel with Docker containers. What exactly that is? So guys, very simple. Container was built from this instruction file. These instructions were copied in the image, and the last instruction was CMD. This CMD will mention any executables to execute by default when container starts using start command or run command. So this executable started, and travel service.class was also started, and travel service was .java was having this public static void main. This output is coming on the console actually. The very simple example we have today, and that is the output you have. And guys, after running this container, that container has shut down immediately because you know your .java file is not running and running and running 24/7. It has been shut down. So if you want to check running container, nothing. But if you want to check all the containers, they're running or not, you can check all the container. You can see guys, container 1, container 2 from the same image. From the same image, 2 containers were created, and about a minute ago it was created, and status today exited about a minute ago, and see different name automatically given. The container has been exited also after running your code. And guys, there are more things available. So if you want to run a run command, it will run the container again. But remember, be careful. Run command always create a new container from the image. Previous container will not be considered. If you want to run start the old container, use start command with that container ID. If you run with the image, a new container will be started. So guys, if you want to run a container, you can run in interactive mode also if you want. See, I'm running in interactive mode. What interactive mode you will understand. In the interactive mode, I'm running with the bash command. See guys, see, be careful here today. See where I'm standing today. Earlier I was just running. It was running with the default command, and the default command was given with the instruction called CMD instruction. Today I don't want to run my container with the default command, which you can override anytime while running, and today I'm doing that only with IT option. When I say IT means interactive mode, you want to run your container, which is a newly created container from that image. That newly created container will be created in interactive mode, and in the interactive mode, this bash command will execute, which is inside the container. See, I'm inside the container and see where I'm standing right now. You have logged into the operating system with the root user, your container ID, and you are in USR Java command. See, you can run ls command here. You can see what all files got copied. .class file was there. And you can run yourself now. Class, you can run yourself. You can even compile yourself. You can even modify. You can modify the .java, and then you can again Java C, and then you can again run Java command here. So you are actually inside a container right now, just running and running and running. You're working that container, interactively. So it's just like. If you have worked with virtual machines in the past, it is just like that inside a virtual machine, you have logged in as a root user, and after logged into the root user within the virtual machine, you are just wandering around, cd ... and all that. Now you're saying pwd, we are in USR folder, then you say ls, you have games and Java folder which was just created. You can see, you can again say cd ... then you can say again ls, you are in root. In the root you have full Unix operating system. The file system is there, in which we are working with a folder called USR, which was having a folder called Java, in which we had our data, the class file, and you can just delete this travel class anytime. .class file, you can delete it. So rm, not delete. In Linux we have rm. All the commands, delete it. Again do the listing. .class is gone. If you do Java again, it won't run because there is no .class file. There is no class file. You can again compile it from here. I have done the compilation. Now I can again run from here. The program is running from inside. Once you have worked with, see, on Windows operating system, I have another operating system. Inside that, I have another container which is Linux based. I'm just coming out of it. After coming out of it, I'm again back into my Docker place where in C example I was working. So guys, your container is ready. You can just check Docker ls-a, ps-a, all the containers. Anytime you can delete a container. Let's say I want to delete this container, that particular container I want to delete, you can delete. Docker rm to remove a container will ask you for the container ID. Not image, container will be removed. Container is removed again, do ps a. See, that container has gone. That container, I created 3 containers from the same image. So one container has gone. Let me delete this bash container also, which I started. See, that default command was that has been overridden with bash command because the last time I run this container with the bash command. Let me delete this container also. If you want to delete that container also, you can quite easily. Yes, I want to delete this bash container whose ID is so and so. I'll say Docker, remove the container, done. That will also delete. Again, say ls. Only one left from that image. And guys, now I want to share this container with you guys so that you can download this container from this Docker hub, and then you can actually use it with the same concept I was telling you. I'm considering myself as a developer. I'm considering you guys as the customer. So as a developer, I want to ship my code and environment together, and that is what I've done. I have a container in which I have my code, which is a single file travel service.class, and I have my environment there called JDK already there. So JDK is there, class path set, code already there. Code can be .java file, war file, whatever. And I want to ship this container to you guys. And if I want to ship this container to you guys, I can do it via the cloud URL called GitHub. If I go to, this Docker hub, if I go to hub.docker.com. So guys, if you want to share your container with others, so you have to do one-time registration here. Choose a new Docker ID, your email, your password. Once you create, then only I have already created mine actually. I've already created mine, so I don't have to. What is this asking? Something is wrong. There is one-time registration only, guys. You have to do one-time registration. Keep your username, password ready. So once you log in, it will hardly take 2 minutes to create a new username, password. After that, you can your username will become your namespace. Under this namespace, sign up. Why sign up? I have to sign in. Sign in, sorry, not sign in. I've already created my account, so I'll sign in. Any container you will upload, any images you will upload, sorry, not container images. Actually, they will all be uploaded under this namespace called Tyagi. That's your Docker ID. Because those containers, I've already uploaded few here. There are few containers already uploaded. 1, 2, 3, 4 containers are there. 1, 2, 3, 4. They're under my namespace, so that if there is another guy uploading a container with the name calc, there won't be any conflict because your containers will be uploaded under your namespace only. So create a username, password, and that you can use to upload containers, and others can download a container without any login ID, without any password. So guys, I already have created my login ID. I've already tested that I'm able to log in also. But there is no need to see. Right now you can see 1, 2, 3, 4. Only 4 containers are there right now. Come out of it. Now create a new development steps. Create a new image using build commands. Create a new container using git and the start commands for command. This is a development cycle, you know, the Docker development cycle. Create a test container and using images and PS commands. Once you have tested the container existing and the container is running, test image existence using image PS command. Docker PS or image existing Docker images command. And now create a new container and create start command or run command. Definitely 2, 3, 4. After that, test container working or not. By checking default CMD command entries. And guys, then, if you like, you can share your container with via Docker Cloud. How? You will do like this. Log into cloud, add your image, upload your image, log out from cloud. These are 4 steps you need to do. That's what I'm going to do right now. As you can remember, guys, it's just kind of webinar or workshop only a little bit, so we don't have to go in much detail. Now, guys, I have already created. This is the development cycle. Actually, we call it development cycle. In Docker, every technology has development cycle. First, a Docker file which will have instructions for building new image. From the instructions, new image. Then create a new image using Docker build command. Test image existence using Docker images command, whether image is coming in the list or not, using Docker images command. You can delete also if you want. You can delete also your image if you don't like it. Create a new container using Docker create Docker start. Test using Docker start or directly using Docker run commands. Test container working or not by checking the output, by checking output of default CMD command. Once you're satisfied that your database container, your Tomcat container, your var container, your Java container, your C++ container, your Node.js container, your PHP container, your NoSQL container, your MongoDB container, your WebLogic container, JBoss container is absolutely fine. Whatever things you wanted to install, they are available. And how they got installed into the container, you will not realize it. They have got installed from the very first line only. When you created your image from base image, and that base image was already Java image, WebLogic image, JBoss image, guys, you go there on Docker Hub Cloud, already multi-million images are there. You name it and they're there. If you think, okay, I will create a container, I will install Oracle database myself, wrong. Then there is no benefit of working with container technology. Where is reusability? Always pick a image which is already there, which has those things already installed, create a new image on top of that and go ahead, and that is how layered architecture. So if you can't use layered architecture of Docker, then definitely you did not understand Docker. If you don't understand how layered architecture works, how Docker images should be based on layered architecture, definitely we are very much away from the myth of Docker. We are little not good in Docker. So very first instruction itself will provide you a lot of things from the base image. which has already many things installed, like Linux file system installed, and a lot of package manager installed, database server installed, WebLogic installed, JBoss installed. After that, you copied your var, jar, rar, er files. You made them working directory. You add your own commands to run, your own run commands to execute in between, like Java C was running. Then you can expose port number, which I did not do. You can mention your name, email address in the label, who built the container, who will maintain the container or image, like that. And then this is the life cycle. And guys, once you are satisfied in your local system, now time has come to share your container with your colleagues or other party or a customer. Now guys, after testing, we have to do that. I'm done with the testing part. I have to share the container to my other team members via this Docker Hub Cloud. Let me do that. Let me share the container via Docker Cloud. These are 4 steps. Log into cloud, tag your image, upload your image, log out from cloud. Let me do these 4 steps. So guys, the plan right now is in my Docker, I am seeing the images. I have an image called travel, which is tagged as 1.0. Remember, you do not have to upload a container. Why you created a container? The reason was testing. See guys, you created a container out of this image, whether your container has sufficient environment like JDK environment or not, Java command working or not, Java C command working or not, and your code has been copied inside the container file system or not. You tested by running this default command. Once your testing is done, I would suggest you can delete this container. By name also you can delete, by ID also you can delete. These are default names given. If you want, you can choose the name. No need to delete. I'm just trying to tell you, you can delete. It is up to you. If you want to delete or leave it. I'm deleting the container. Done guys. Again do PS. Container is gone. See, from that image travel containers, there is no container. Gone. You don't have to share the container. You created container for the purpose of only testing your container. See, it's quite obvious, guys. It's a rule. Test your code before you upload. That's what we always follow. I'm following TDD. Test my work I want to share before with others, so that they complain your container not working, your code not working, your environment is not proper, your path class path not proper, your container is not having proper configurations inside. Other people complain. Why not to test first? I tested. From the image, I created a container. I tested my container working or not. So that test which I did, run container, has given me 2-3 things. Container has sufficient JDK installed. Java path class path has been set. Code has been copied inside the file system of the container, which is a Linux file system. And I'm able to see the output also on the container. I was able to run container in interactive mode, non-interactive mode. When you run in non-interactive mode, default command will execute, which was Java command. If you run in interactive mode, then you can do anything inside the container, just like a normal virtual machine you do, because you can go through file system, CD, delete, rm and all that, compile things, create new files, etc. Once I've done the testing, guys, now makes sense to share my image to other guys, and that is what I'm going to do right now. Before sharing the image, I have to check whether that image exists or not. So yes, guys, image is existing. Image name is travel and the tag is 1.0. To share, I need to share via Docker Hub. I can't share via Docker Hub until I have an account on Docker Hub. Like you can't upload any code on GitHub, you don't have an account on GitHub. So guys, I have my account on Docker Hub I just created. It takes only 2 minutes. Will ask you for a Docker ID. Email address and password will create a new Docker ID for you, and that Docker ID will become your user ID we have just seen. So guys, what I'm going to do is I'm going to share my container right now to Docker Hub. You can see it is not uploaded till now. It will upload now. So to share, you first have to do login. Docker login. From command line, you have to log in into Docker Hub. Because if you don't log in from here, that way anyone can upload a container into anybody's user ID. That's what we don't want. So I am just logging in first, authenticating using existing credentials. Login succeeded. It is not asking me. Let me tell you the reason, because I keep logging and it saved my login information already in this folder. See, in C user i2 tyagi docker config.json, it is already keeping my username password. It picked from there and already authenticating me. But when you will run first time Docker login, it will connect to docker.hub.docker.com and will ask you login name and password both. If they are correct, will tell you login succeeded. but it did not ask me because it picked my username password from this file. For the first time, it will always ask you can try it when you say Docker login. So guys, from command line, I have logged in. So Docker Hub knows me very well in this command window. It's a session window now. In this session window, I can upload something. So guys, before uploading my container, I have to tag my container. You can try uploading, no problem. Docker, upload it by using Docker push. Give your container name, travel colon 1.0, and it will deny. Just see, push it, it will deny. I have a container, I have an image called travel with a tag name 1.0. When you say push, it will push this image on Docker Hub. You don't have to give where to push. You don't have to give the URL. URL is always hub.docker.com. It will always push your image there so that others can download. Enter. See, it will not. Will give you an error. Wait. You will get an error soon. See, denied, requested access to the resources denied. Actually, why it failed? It tried to push the image under this URL, docker.io library travel. Library is a folder which is for official containers by Docker Hub community, and that is not my access permission in that particular Docker, this official library folder. I don't have permission, so I can only upload container under my username. That will become namespace for my container. That is the reason first I logged in. But if I logged in, it should have pushed my container into the login user. No, that is not the way. Actually, your container name should reflect your username also. So what we need to do for that? One extra step. What is that extra step? The extra Docker. There is a command called tag. You can tag image anytime. You can rename your image anytime by giving a different tag name. The original tag is travel version 1.0. I'm giving a tag name as Tyagi. This is very important. Very important. Tyagi oblique. Oblique will become a namespace. This will become namespace means username. When you are giving when you are creating a new when you're giving a new name to your image, in the new name your username must reflect. So new tag name has username, then your image name. Let's say image name is travel only, and let's say the tag name is, let's say whatever tag you want to give. Let's say the tag name is 2, for example. What is the name is 2? So username and then image name and then tag name, tag version name. That's all. Enter. So that old image will be tagged with the new image. So there will be 2 images in the local system. Done. If it is done, again check. Again check PSA. Sorry, not PSA. Sorry. Images. Docker images. What all images you have? See, you have an image travel 1.0. That was your old with image ID. There is a new. See it. You can see that image ID. B69EC3A7CF83, same image ID. Because from the same image ID, you created one more tag. If there is a username reflecting and then tag these 2, today you can push it. You have already logged in, you can push it by this. Tyagi travel and 2. Push it. It is pushing under the login name which we have used for login already. We have already logged in. So it's pushing right now. Earlier it was not pushing. Whatever is the size, it will take a little time. It will push it to the Docker Hub, from where, guys, you can download. I don't know whether anyone out there who's sitting right now is having a ready system, laptop is there and Docker already installed. If anyone is having a system, Docker machine already, Docker client already installed, right away you can pull it and right away you can just run it. And then I'll tell you what you achieved. It is uploading it. It is pushing it that the entire image is being pushed. See under this username, just check here. The username is this Tyagi, that becomes the namespace, and the image I'm pushing is travel, and I have permission on this username because I've logged in. That's why I'm able to push. That way, no one can push an image into any other username until you log in. I just show you one example of one container. So that way we can create container for Tomcat, container for Node.js, container for Database Oracle, container for WebLogic, for WebSphere, container for PHP, container for ASP, for .NET, and then we can push on there. Create image, create a test container, test it, delete it, login, push after renaming it, and then tell the entire world there is an image available. That image is ready to be used. That image can be used anytime and can be downloaded anytime. It'll take a little time and then I'll show you. Wait. So guys, it is not easy to share your virtual machines. Let's say I had created a virtual machine using VirtualBox in which I was having Linux operating system installed. On top of that, I was having JDK installed. In that, I was having my .java.class file also. And now there was a time to share that virtual machine with you guys. It was not so easy like I'm doing right now here. It's first of all lightweight, and we have Docker Hub Cloud through which I'm sharing it. And you can just pull it and then you can just use it as a container. Any day you can delete the container, environment is gone. So that is another benefit of Docker. It will not disturb your local machine environment, and still you can work on a different project anytime. Container one different project, container two different project. Any day you can discard, and you can do testing. You can use them for staging purpose. You can simulate production environment. You can simulate testing environment, and your machine, physical machine, will be intact. That is the beauty. Every day a lot of containers again. Google creating almost every day around 10,000 containers every day, create in the morning, and in the evening those containers are deleted. A lot of developers do R&D, a lot of machine they create, a lot of container they create, they do R&D, and then they go. A lot of money is being saved by these big giants by giving container-based environment wherein you enter into their cloud, you create a machine, you do some R&D, and in the evening you log out, you delete those machines. That's nothing but some containers. That's all. See, it is done. This is a container digest value and the container size 2414. Let me check. See guys, that is what I did. Share the container by Docker, log into the cloud. I did it from command line. Tag your image. We did it. Using username. Upload your image. Log out from cloud. If you want to log out, you can say Docker and there is a command called logout. There is no need. If you want, there is no need. You can simply say logout. Removing login credentials. Done. Guys, if you want right now, the container has been there. Docker hub.docker.com. I will log in under my credentials. Already logged in under credential. I've logged in, and yeah, you can see updated a minute ago. It is a public image, and if you go inside this image detail, click here. There will be detail here. The container name is image name. Sorry, not container. Image name is travel under this username, and it has been tagged with a version 2. And it has been pushed like this: Docker push and Tyagi and travel and all. And this is the information you have, and you can see all the tags. If you want, you can see all the tags of this container. The tag, that image was tagged with the number 2. That tag was made 2 minutes ago by a username called so-and-so, and that image is based on Linux operating system. So that Java image is basically running Linux based on Linux operating system. And that image has been uploaded here with a compressed size of 235 MB. Image ka size is compressed size. Overall size was around 2414, but it is around right now compressed size is 235 MB only, and that is the digest value of this. And guys, you can see general information about the container, tags under which this container is available, version 2, version 5, builds, automated build. See, automated build can be done from here if a Docker file is available on GitHub or Bitbucket. So these containers can be used for automated build also. Timeline, definitely no timeline right now. It has not. I can add collaborators here. Other Docker ID I can add here as collaborators. They can also upload into my repository if they want. If I make them collaborator by giving their Docker ID here, I can give them permission. So like that only. So I have this container. So guys, what we can do right now is, if I go back, the cycle is, if you have tested from here, check Docker images. Now let me say Docker RMI. I want to remove image, not a container image. RMI means remove image. Image name is Yagi oblique travel and 2. It will be removed. Then I want to remove another one also, which is travel and 1.0. That image is also gone. That image is also gone. I will check images again. Images again. See guys, those images are gone. If those images are gone, in my local system, I don't have those images, but I'm sure they're available. I've already uploaded my image on the Docker Hub. Any day I can just get from there and I can use. So see guys, that image is not there. If that travel image is not there, I can't create any more container out of them. So my code is also gone, my infrastructure is also gone. Code and environment both gone because image has been deleted. So let me play the role of other side developers or other side customers. So those customers or those developers who want to use my content, let me play that role today. So see guys, I'm playing that role. Today I'm not the container creator. I'm not the image creator. I'm considering the fact that there is someone who has uploaded that container, and today I need that code in my system to use. I want to test it as fast as possible. See how easy it is. Pull container from there with the name travel with a tag name too. While pulling, no need to log in. Anyone can pull. That was a fully qualified name. I'm pulling it, guys. I'm playing the role of other party now. How other parties will download your container? They only need to install. They only need to install Docker machine. That's all. See, I have Docker machine installed, and I'm trying to pull container from Docker Hub. I'm just getting it. That image. See guys. Configuration dial TCP to the lookup. Timed out. Oh, internet connection, I think. Issue. So it's so easy to pull, and you can't pull only the container, sorry, the image you uploaded. You can pull any container which are already there. I will help you to pull other containers also. There are many available. A lot of containers are there. So guys, it is so easy just to create the containers. I think there is a net issue right now. I think so. It should not take that much time. Yeah. Okay, that's all. Just let me check other. If this container size is quite heavy, that may be the reason. Let me download other container. Hello world container is there. That size is very small. It's already there. And if I don't give the version or tag, it will be the default one, the latest one always. This container is a lightweight size. I'm pulling it. I don't know who uploaded, but I'm just trying to tell you, if anyone uploading an image out there, you can just download that image anytime. So pulling from library hello world. Maybe I had pulled it already, so that it says already exists. Yeah, download new year image for latest, got it. And after pulling it, guys, anytime you can run it. It will create a new container from this image. See how simple it is. Same way, see container is running. Hello from Docker, so and so, like that. For example, I want to pull one more container tomorrow. Let's say I will pull a container called CentOS. There is already a container, sorry, image called CentOS. That image, as the name suggests, has CentOS flavor of Linux file system, CentOS flavor. It is containing all the package manager of CentOS, whole full file system of CentOS. I'm pulling it and then I will run it. So what I'm trying to show you is how simple it is to share things. It has been pulled, guys. After it has been pulled, I can run it in interactive mode. Let me run in interactive mode that CentOS, and let me run in interactive mode bash shell script. I want to run in interactive mode. I want to talk to bash shell script. See, I'm into CentOS operating system right now. Inside CentOS operating system, I'm standing on root. If you say pwd, You can say ls. You can go anywhere, anytime, like cd, for example. You can go under sys folder. You can say ls. So easy it is. You can go under dv. Just try to say ls. It's so easy, guys, to inside that content anytime in interactive mode. Now I'm coming back, and if you see here, I can just check Docker how many images I have in my system. So many images I have. So I've got an image CentOS is there. Tag is flavor, the latest. I did not give tag name, that's latest. 4 months ago it was uploaded by someone there, and the size is 237 MB. So just trying to show this cycle actually here with the help of this. So guys, let's not go in much detail. It was just a kind of small workshop, a small webinar just to show you how this technology works. So it's very different from the virtual machine. So if I go back here now, let me just complete it quickly. Then I will have questions from you. Agenda I was saying Docker, Docker name, Docker, how Docker is different from virtual machine. See, now you can understand a little bit. With the help of Docker engine, I was able to create my container, and container was already having required libs and application code, required lib one more container, required lib and application code, and Docker engine. But in previous virtual machine technology, within virtual machine, first operating system, then lib, then application, operating system, lib, and that's why those virtual machines become heavy. So one host operating system and then guest operating system. Virtual machines heavy, can't share. Creation time takes, a lot of things are different. We have already discussed this. Docker can run on so many platforms because it's lightweight. I already show you how you can transfer it through the Docker Hub, guys. If you already have laptop, simply run Docker pull command. That container, that image you can download, and then you can run the code with the infrastructure, code with the environment. You don't have to do anything in your system, and you can run. We have seen Docker features, Docker architecture. Yeah, now you can understand it. So from the Docker client machine, which was my machine only, as a developer, first I created a Docker file. You can see, once Docker file was ready, then I was building the image, I was running the image, I was pulling and pushing from the client. Whether you build or you run or you pull, you push, all the command from the client go to Docker host. On the Docker host, always daemon is running, Docker daemon is running. That Docker daemon will create images, and from those images containers will be created. So you can see on that Docker host we have daemon will be creating images and containers. All the command from client will be coming to daemon only. And guys, if you want to upload your images on the cloud URL, Docker hub URL, then that pull command, push command, Docker push will go to daemon, and daemon will push that image to the repository. That is the Docker registry, which you can see. See, there is a Docker registry which is there, wherein you can push or pull from. Otherwise, where container images, how images come in Docker host machine, those images from Docker host, they come from, they're pulled from Docker repository like Docker hub.docker.com. You can push, you can pull. That is the Docker registry, which is nothing but the Docker cloud hub.docker.com. So now you can see the entire architecture, which we have seen practically, that you can see into this picture. Client talking to daemon pulling, pushing container images from the Docker cloud, which you can say Docker registry also. Already many containers are there. You can see Node.js container there already, Redis container there, Ubuntu container, PostgreSQL container is there already. And then I made you aware. Now you can understand a little bit about engine, client, daemon, Docker file, Docker image, Docker containers. See, now you can understand hello world container, Docker run, container name, image name Ubuntu, and then echo is the command. You understand Docker image command, what it does, Docker ps command, what it does. See, if you want to work with images, some command, Docker images command, list all the local images, run tag command, tag an image from an old tag to a new tag. You can pull RMI. I've shown you all the command. RMI command I show you to remove image, pull to pull image, to create a new image from the old image, to run the image, to run the container from the image, images to list the images. See, container commands. These commands apply on container. How to start? There is a command called Docker start, Docker stop. They will need container ID actually. Start stop, they will need container ID. Then PSA, PS command, pause. I did not show you, but RM command we have seen how to remove a container. That's how. So that's all, guys. And the role of Docker file, we have seen create images automatically using a build file, which is Docker file, can be versioned in a version control system like Git or SVN. That is beyond the scope. But Docker file you can keep in GitHub from there. Docker Hub can automatically pull it and automatically can build images out of it. So build creation can also be automated by keeping Docker file under GitHub. That is another advantage, or any other SVN and any other SVN source code repository like Visual Source Tape or ClearCase or CVS. Docker file example we have already seen. Create an image from this base image called Ubuntu. Set some environment variable within a message with this value. Add some file into this directory from this directory. Some command like that only. Docker build, which will need build directory. Docker file directory from where. Then you can inspect an image which has been created. Like that. And then you can run. Then you can run a Docker container from the image from Ubuntu image you are running in interactive mode. We have seen these commands like how to bind how to configure inbound protocol with outbound protocol. So this I will share it. No need to just discuss each and everything. And around Docker, there are more things available. Docker ecosystem has Docker Compose, Docker Network, Docker Kubernetes, Docker UI. You can automate setup using Puppet, Ceph, Ansible. And like that, you can have Docker virtual machines on Vagrant also, definitely. You can have Docker images on Docker Hub. We have just seen. This is Docker Hub URL hub.docker.com. And Docker these are some use cases of Docker where you can use Docker in your development environment for integration testing, wherein you don't want to disturb your physical machine, and still you want to create integration test cases for different projects. So you can create all integration test cases within Docker container. Once testing is done, delete Docker container and without touching your local system at all, they will be intact. Quick evaluation of software, another good use case. Your company is giving you a responsibility to evaluate new software, new library, whether they're workable or not. Why to disturb the physical machine? Why not to download those software in a Docker container, evaluate them and delete Docker container anytime, any day without having any disturbance in mind that the system will be broken. To deploy microservices, someone was asking me a question. To ship microservices, use Docker containers. They're used very heavily. Multi-tenancy, definitely. Multi-tenancy. Different services of the same project can be used in different containers. Unified execution environment for development, different container, testing, different container, production, different container, local machine, different container, VM, different container, cloud, different container. And that's all about it. A little bit on Kubernetes, guys. Kubernetes is a container management system. Docker is a container technology, but how to manage multiple containers, that is what is Kubernetes. So if you have a lot of containers, it will be not easy to manage them individually. If you're looking for a tool to manage them, then go for Kubernetes, which is a very nice infrastructure technology which can help you to manage a lot of running Docker containers quite easily, connecting them together, making a cluster of them, starting the cluster, shutting down the cluster, auto scaling. So many benefits you will be getting using Kubernetes. So Kubernetes is another tool by Google, which is an add-on on top of container technology. Because right now I show you one container, you find it easy, but what if the number of containers are 100 or 200 or 20 or 30? You want to start them, you want to stop them, you want to check them, their health, you want to check their log, you want to stop few of them, you want to connect with them, you want to manage them properly by sitting on one machine. So that is where Kubernetes comes. It is a container management system developed in Google platform, is to manage a containerized application, various types of physical, virtual, cloud environment. So why Kubernetes? You can run Kubernetes on premise or bare metal or OpenStack or public cloud like Google Azure. Definitely it will help you to avoid vendor lock issues. You don't have to enter into vendor lock-in issues because Kubernetes is a standard technology. It runs on any vendor systems. It enables applications that need to be released and updated without any downtime. That's another beauty, guys. Scalability, actually, here this point is about scalability only. It allows to ensure that containerized applications run where and when you want to have whatever resources you want to have. See, these are the features of Kubernetes which you will not have in Docker. Docker is just a technology for containers. See, why you will need Kubernetes and Docker together? Automated scheduling, self-healing capabilities, automated rollout and rollback, scalability and load balancing provided by Kubernetes for your Docker containers will be load balanced and horizontal scaling can be achieved. Offer environment consistency for development, testing, production. Infrastructure is loosely coupled to each component, can act as a separate unit. Higher density of resource utilization that you can decide enterprise-ready features, application-centric management, auto-scalable infrastructure. That's very nice. You can create predictable infrastructure in advance. So Kubernetes and Docker, that is a very good combination nowadays. Are being used. So Docker for creating containers, to manage those containers, are load balancing, to manage their failover conditions, to manage their self-healing capabilities, to schedule containers, when to execute, when to shut down, to scale the infrastructure, scale up, scale down, scale out. These things can be managed very well by using a tool built by Google called Kubernetes. They're used together actually. This is the architecture of Kubernetes. In Kubernetes, we have a master node, and that master node will manage slave node, node 1, node 2, node 3. And in every node, we will have pod, and every pod inside will have a Docker container. Pod container, and one physical machine means more node 1 can have many pods. So that way, from single master node, you can manage all the slave node, and each slave node can have multiple Docker containers running inside pod. So pod is nothing but a process which is managed by node manager, and node managers are managed by master node. Just the overall architecture, if you understand. So one machine, single machine, centralized management of all the containers, which you can't do only just alone using Docker. That's all, guys. From my side, thank you, guys. Now let me take your questions. So the purpose was to remember, guys. Again, I would repeat it. Purpose of this particular session was not to give you the mastering of this technology stack, was to give you a little bit knowledge so that you understand it from the perspective of what this technology is, how it is different from other counterparts, and so that you at least in this 2-hour session you at least understand something about it. You will understand at least something about it. So before just we go ahead. So guys, I'm done from my side. So now I give time to you. You can have any questions. You can go ahead one by one, guys. So the webinar is over. I'm done. So the purpose, what is container, what is Docker, why container technologies, how they benefit, business benefit, developer benefit, infrastructure benefit, system team benefit, client benefit, hardware benefit. So that was the example. Remember guys, the example which I was showing you, example was not the purpose. Example was only to give you little bit of practical work so that you can correlate. Example was not the purpose. Just was the purpose was to give you the overall idea about this technology stack. Let's go ahead. I'm done. You can ask your questions. Time is to you now. One by one, you can go ahead.
So Ritesh, if I have multiple containers all running on a particular framework like .NET, so my .NET framework has to be part of all that containers?
Good question. So what we'll do is we will create one single container only, which will be .NET container, one single container. And then whatever project I will create on that .NET framework, then I will create for each project, there will be, let's say 10 projects. All of them need .NET. So I'll create 10 container. They will be based on that .NET container. It will be like that. .NET container will be separate, which will be inherited by all other 10 containers which are actually which are having .NET code. So that will be your base container. .NET container will be only one.
So Ritesh, if I want to create an which has a legacy version of Apache server and maybe Python and other similar versions, the whole ecosystem. So how, and it's this image is not available readily on the Docker repository. How can I create that?
Yes, definitely. Then
so how is
then if you start from the container, which is a operating system container, OS image container. Let's say if I am in,
it's a Linux.
If I'm doing it, I will create a container from Ubuntu image or CentOS image or let's say Fedora image, and I will myself run inside apt get command using run instruction. There is a run instruction. With the help of run instruction, I will run apt get for whatever PHP version inside that Ubuntu container or CentOS container. You have to run apt get or yum package installer, so that in that base image you are installing yourself the required software using apt-get or vim installer. We don't have an example because that was not the purpose, but apt-get or vim installer you have to use inside the Docker file in the instruction so that your purpose can be solved. I hope you got it.
Yeah, I understood. Yes.
Actually, run instruction is there. With the run instruction, you will run that command or yum command. They will download, PHP or IIS or PWS or HTTP, whatever server in the original base image, which is Ubuntu or Fedora image or CentOS image. That way, your container will be ready, and then you can even upload all.
So Ritesh, do we have some default space being allocated to containers, like how, because we are having things inside containers, so how that space is being allocated?
Okay, all right, okay. Actually, by default, there is no provision of that. By default, let's say I took a base image whose size was around 650 MB, right? So 650 MB image, and I copied one jar file inside through Docker file in the container which I'm creating. And the jar file size is 2 MB. So 650 plus 2 MB, 652 MB image I will have on overall when I will have my image file. So it is just add-on on top of the base image size. By default, if you ask me how is the size decided, so base image size plus the jar, var, rar, er, or anything you copy, that size will become the final image size. It is how it is always. And if you want to control, there is a command to control that also while creating an image. Actually, you have a command option -m. M stands for memory limit. So with the help of that -m memory limit option, you can set the memory limit. If you want to control, it is controllable. Default is fine, and control it can be controlled also. Both options are there. Any other question that you have locally? What is the copy? What is that?
Ritesh, I just have a question about the containers writable layer. So how the writable layer functions on a container, and what is the use of that layer? How does it interact with other containers?
Which layer? Which layer?
Writable layer.
Writable.
Yeah.
What is writable exactly?
A layer where how the containers interact with each other in a cluster.
Guys, those guys who are not speaking on mute, please. Those who are not speaking on mute, please. There's a lot of noise coming. Yeah, now good. Yeah, go ahead. Now you can ask your question now. What is writable?
I was just asking that how the the communication between containers takes place. If we have a cluster of container and the application needs to talk to each other, then how does that happen?
Okay. Actually, for that there are two steps involved. Step number one is inside the container you have to use expose instruction, which I did not use because that was not my requirement. There is expose instruction which will expose a container to a port number. That is very first thing, and that port number will be mapped with an external port number. So step number one is expose instruction. Step number two, when running the container, map the internal port number with the external port number. But that is not enough. One more step has to be done, and that step is known as container link. So when you have container A and B running, so while running container with the run command, there is an option called -link that will ask another container the name to link together. Only port number and IP will not be enough. So three-step process. Expose has to be used inside to have internal port number. While running, map it with an external port number, and don't forget to use link option when you want to link two containers together using the run command. That is how you need to communicate to how you will have two applications running in two different containers communicating with each other. So using link, you can just do that. Or another solution I can give you, better solution if you don't want to get into this mess, there is one more solution you can use. You can use actually Docker Compose. There is a tool by Docker community called Docker Compose, especially designed for this only. That makes it easy actually. You don't have to do these things manually. Second option is that. Third option, If you don't like Docker Compose also, then I will tell you third option, go for Kubernetes. Kubernetes can do it more easily actually. Kubernetes ka purpose is that only, so you can use code. So these are three options. Without Docker Compose, Kubernetes you can do it. With Docker Compose you can do it. It's a tool which is downloaded and you can use it and using Kubernetes. Any other question guys you have? I hope I give you answer. Any other question guys you have?
Ritesh, one question, like in the Docker file, like can we have it from multiple images, like as a base image?
No,
Like,
only one. No. From instruction will be only one base image, just one. You have to do multi-level inheritance if you want. Multiple inheritance not possible. Multi-level you have to do. Image A will be based on B, B will be based on C, C will be based on D, but it will not happen. D is based on A and B and C and all. Not because from instruction comes only once. Any other question? I hope you got your answer.
Like Ritesh, one more thing, like
Yeah, go ahead, please.
Ritesh, couple of systems needs to have a higher performance. So like using Docker, how we can manage that?
See, when we talk about performance, this is actually a very general term. In what sense actually you're looking for performance? I will be able to give you more concrete answer if you give me more concrete question. It's just a general term.
So
Performance
like
in terms of memory, or what?
In terms of CPU processing speed and memory, yeah.
See, if you go about CPU processing speed, that question is already answered. If I do the same thing with virtual machines, when you create a virtual machine using VirtualBox software, VMware, or parallel software, when installing operating system in a virtual machine, you have to mention physical CPU, amount of CPU that VirtualBox will use or VMware will use. Here, that is not the case. Container does not have operating system inside. You don't have to tell container how much CPU it will utilize. Actually, all the command, that is the difference we I think missed. All the command from the container are going to the underlying base operating system only, and base operating system will use physical CPU, physical RAM, physical hard disk. So if you talk from that perspective, that doesn't come under the control of the container. That comes in the control of your virtual machine, VirtualBox, and parallel software, which were old time virtualization technology. So here it is better. In what sense it is better? Containers are lightweight. They don't have to take care of this. They don't have to worry about this. Let underlying operating system already talking to CPU, hard disk, and memory. And from that perspective, even if 10 containers running on my operating system, each container is lightweight, and they're all sharing same CPU, same hard disk, and same memory. So they're lightweight and they're faster. So speed wise, so they are already good. And actually, there was a slide also for that I was showing you. Here, let me show you again. There was a slide also. I will just show you that. In that I mentioned this benefit of Docker specifically. That was here, I remember. Yeah, this one. Speed. Already Docker containers are quite lightweight and they are fast speed wise, because of the reason is they're not just like virtual machines. That physical CPUs and physical RAM is not divided among multiple containers. They all use the same underlying OS. Is the ultimate environment for all of them to execute. So they are lightweight and they are fast. So speed wise, you don't have to control it. Operating system will take care of it. There is only one operating system in container technologies. In other technologies, multiple operating systems are there. At the other hand, you can take care of performance things if you want. For example, minimizing the size of your jar, var, rar files. For example, uninstalling those layers from the image which you actually don't need, like that only. You can take care of these. Okay, any other question? I am having a question from Vatsal Sharma. You local would still have the copy downloaded initially to the image rep. What is that question? What local have still the copy?
Oh, no, actually, that was
I have one more question.
question.
Because if you delete Your image local is gone. It's gone. It's not that. Can we have two programs like Java in one Docker file? Yeah, we can. We have a lot of programs in file. One default other run in active mode like I run, if you remember. I joined my container in IT mode, if you remember, -IT, and then I myself was able to do inside container Java C command, Java command on different files. So you can copy a hell lot of Java files inside a container. One of them will be default, which will execute when container starts with CMD. That CMD instruction will be default instruction, but that instruction can be overridden any time when you want to run container in interactive mode. So just to give you the answer, I hope you got your answer. And Sandeep Kumar is asking one thing. In your case, you choose USR travel. How we can choose copy command directory? A lot of questions I have here. Let me answer one by one. Better you ask because chat has been very big. Actually, chat has been big enough. So better you ask your questions, guys. Chat is big enough. I'm not able to.
Jai here. I have one question. So, yeah. So, how to achieve the multi-tenancy if I have one application deployed using Docker Compose, in which I have, for example, ELK setup. So Elasticsearch, Logstash, and Kibana. So how would I achieve the multi-tenancy where I only one instance is running, and I will be able to serve multiple tenants with different, metadata?
You meant to say within the same container you want to serve multiple applications for multiple clients? That is your question?
Yeah.
Okay, that is easy again. Within same container, actually, this is a webinar. If it was a training, I could have told you, but you're asking, let me give you concrete answer only. Actually, within container, when you want to expose to multiple clients outside world, it is compulsory. Container should have an expose instruction, which will expose your container with a port number. So this container has been exposing itself with a port number 5000 to the outside world. But exposing with one port number is not enough. You can expose multiple port number from the same container 5003, 5004, and you have exposed multiple port number. How to map them with the external port number? That we do when we run it. And what we do is we give different port to different tenant, different client for the same container, and internally I know what I have deployed. I'll not deploy Java C and all these kind of things. I'll deploy some var or REST APIs and all, and I know how they are running on different port numbers. So that way multi-tenancy can be achieved very well using expose itself, because it does not accept only one port number. You can actually expose multiple port number also for the same reason. That is the only reason we have. I hope you got it.
Yeah, that's cool. Thank you.
Yeah. And we have one more question. Vikas, speak out your question, please, if you can.
Yes, it is. Suppose our front-end application I deployed in Docker, right? I make it containerization, but my database is still not migrated to the Docker container. It is still present in another server, right? So can we integrate the database connectivity from means
Yes.
to?
Yes. Ultimately, let me give you answer right away. You see right now, if I do IP config here, see, I'm inside Docker CLI. Docker CLI, I am able to know my machine, actual physical machine IP address on which my database is running or anything is running, which is 192.168.561, which is reachable to my Docker client and Docker daemon. And if I do Docker machine IP, you see the answer. You see right now. You see right now. When I run this command Docker machine IP, see it is a different IP, 192.168.99, and that is 192.168.56. That is my actual physical machine IP, wherein we have DB and all that. This is my Docker machine IP. So both IPs are different and both are reachable. if you want, you can go for that. But generally, we don't do. We don't do. The answer is you can, but we don't. The correct answer is better to have that DB in a separate container, because that is when we have to completely go for container-based environment only. But answer is yes, also you can do, but best practice is not to do that. I hope you got it, because see, Docker machine has a different IP, and your physical machine has a different IP. So remember, if there is anything running in my Docker container, any database running or anything, remember I can't use this IP at all. This is my physical machine IP. Even if port number is correct, I must use this IP address to talk to either web server running my container, whether database server running in my container, application server running, JMS server running, PW server running, anything running, I must use my machine IP address. Okay, any other questions, guys? Please go ahead.
Hey, Ritesh, just one question. So it's about the deployment, or kind of, let's say about the upgradation. If we want to update any application or deploy to a already running container, so is it deploying on the same container, or we create a new container and run that with the
No, same container. If you already have an image, from the image you already have a container. In the container, you want to do some enhancement, you want to do some additions, you want to add some more application on a running container, you can, no problem. Same container, not even image also. Image is static in nature, container is always dynamic in nature. The image is just like a Java class, container just like an instance. And in a running container, you can do more additions, deletions also. So that is absolutely allowed here, because that is required actually. So you can do that easily. So don't need to create separate image or separate container. Any other question, guys? Keep on going, keep on going. One question is completed. Second question, you can go ahead. Anyone who has. I can see long list of questions.
Yes, I have one more questions regarding registry. So suppose I have created a private registry for storing my images, and
Correct.
and suppose one, as you said, the image is layer of so many images, and particular tag is no longer required, and I remove that particular tag, and then I run the garbage collector, then what will actually happen?
From the local repository, you deleted the image. That's what you want to know. From the local repository.
Yes. Yeah, so I delete the image, but actually
from the local repository, right?
Yeah.
Local
blob
means
private.
Local RM or private. There are two things. Local is different, private is different.
No, I'm talking about private registry.
Okay. So if you delete the image from the private repository, still if it is there in your local, there is no problem. If it is not available in local also, because you already deleted, and today you deleted from private, it is gone. Image is not available at all. And you did not have it in global also, which is hub.docker.com, because there are 3 repositories you can have in Docker, just like Maven. You can have local repository and remote repository, private repository and central repository. So you have to have it somewhere. If it is not in private, make sure it is in global repository, which is hub.docker.com. Otherwise, you won't be able to grab it. Means you won't be able to pull it, as simple as that. After deletion, no, will not work. So make sure it is there. And someone is asking
So
me.
how to enable? Hi, this is Karthik, Ritesh. So how to enable scaling for this Docker containers, auto scaling?
So if you want to go for scaling, simple answer is go for Kubernetes. Very simple. Docker does not support. Docker is not for Docker is a container technology. Scaling.
Okay.
So go for, if you want to do manual scaling, go for Docker. This one, what we call Swarm. If you want to do auto scaling, go for Kubernetes. Both options are there. Both have their pros and cons. Swarm is also there. Docker Swarm is a tool by Docker community. Kubernetes is a tool by Google. Both of them are there, but one support manual scaling, one support automatic scaling. So requirement ke upar hai which one you want. You have to use either Kubernetes You have to use either Swarm. Both of them support scaling, but Docker does not support because it is just a container. As simple as that. You need to use these
Okay,
tools on
thanks.
top of it. Yeah, these tools are required. Without that, you cannot achieve. Swarm or Kubernetes. Any other questions, guys? I can see one question here. Someone is asking, can we take a tea break for a few minutes? Now already break is there.
Yeah. So like Ritesh, one more thing, like suppose like organization wants to have the CI/CD and Docker, so both are interlinked, but at an initial level, how we can get started for that, having CI/CD implement.
For CI/CD implementation, what you do is create a Docker file. In the Docker file, install your CI/CD software. Inside your image, Docker image, install CI/CD software. Like I do a lot of training on CI/CD myself. I do training on CI/CD on premise system, bare metal machines, installing Jenkins on my physical machine, setting up Maven on my physical machine, Git and JUnit and this Sonar Cube on my physical machine, and then I set up CI/CD pipeline. I do with Docker also. There I install Maven, Git, Jenkins, Sonar Cube, JUnit report and everything within a Docker container so that I can share my entire setup with other colleagues of mine. That I can take my CI/CD pipeline with other colleagues or other system anytime. That you can do on cloud also. Today every cloud support Docker and you can create a Docker container for CI/CD pipeline there also. If you ask me from where to start, from the perspective of Docker, simply create a Docker image. Inside Docker image, install Jenkins, and it is not very difficult. I can just see the hint. Hint is this. Already there is an image. Right, there is already image. You have to start from here. I hope you can see the screen. On Docker Hub, there is already Jenkins. So make sure you create your own image from Jenkins, and then what you will copy? What you will copy? You will copy all your var and jar and everything which need to be run on basically the environment. You have to have Maven also inside this image in Jenkins. I'm sure about it. This Jenkins image which you will be using, that already has all those things available, and Maven, all the build tool like Gradle, like SBT, Scala build tool like Apache Ant builder tool, all of them are there. The only thing you need to just set up your CI/CD pipeline within the Jenkins, copying your Jenkins file. Nowadays we don't use Jenkins UI, actually we use Jenkins file, which is already having instruction for your pipeline. So Jenkins file will have a build pipeline, and then you have to expose your Jenkins port number, Jenkins port number running on Tomcat from here outside, so that Jenkins UI can be exposed from the accessed from outside. And what you will be having here? What will be having here? You will be having here Java. What will be having here? Hyphen jar. What will be having here?
Jenkins.war.
Absolutely. That's what. When you will run this container, it will start your Jenkins. Your pipeline, the file, Jenkins file has already been copied. It's running, and the Jenkins UI has already been exposed from the browser. You can access your Jenkins UI. Pipeline is ready, and the benefit is you can share this container, this image with anyone. We prefer Docker only. I'm telling you, every day in the morning on Google Cloud, 10,000 Docker containers are created by people like me, like you. I go to Google Cloud, I log in. I want to practice something on MySQL. I want to run some insert query and update query. I want to check things are working or not. I create a new machine. Actually, for you, it is a machine, but practically speaking, it is just a Docker container. Those guys have created on Docker, Google Cloud. You did R&D, you did some Java command and all. In the evening, you are satisfied. Okay, my work is done. You delete the machine. Actually, you're deleting the container. See how much cost they are saving every day, how much infrastructure they are saving, how many manpower, Google, Amazon, Azure cloud they are saving. Every day, a lot of container Docker container created morning and evening. They are deleted by the developers. See, what if these container technologies were not around? The same thing would have taken a lot of time and a lot of infrastructure, a lot of money, and a lot of manpower involved. But today things are so simple and so fast. That's what we do. So I always prefer testing new things or anything inside a container. Even if you are on a home PC, you should always try anything anything, don't install anything on your home PC at all. Keep it intact. Even if you want to install Java with Docker container, Node.js Docker container, Tomcat Docker container, database Docker container. Reason, I'm done in 2-3 days. Simply delete the image. Docker RMI, image is gone. My system, project system is intact. My project system, no environment change, no messy things in the environment variable. That is very good use of Docker. Developers are using actually. Keeping their developer, production machine or office system ready for office work, and still doing a lot of R&D on different projects, and different kind of testing and work can be done easily by using Docker. This is how you can do when you ask me from Jenkins from where to start. Start your image from Jenkins image, and then try to run Jenkins bar like this, and try to export Jenkins UI to the outside using export. And from outside browser, use ITAT and Jenkins URL with the IP address of the Docker container. Simple, very simple. Still, this is not a training on Docker completely. Otherwise, I teach all these things. You can understand. I gave you only one example just for the sake of that people should have some little hands-on also because from theory you can understand. But these things are done when you have full-fledged training. Actually, we teach all these things practically. Running multiple containers, setting up cluster, creating links, etc. We do always like that. Any more questions, guys? You have?
Like Ritesh, one more thing. Like, thanks for that sharing the Jenkins example. It's really good to understand. So, like on Windows, we are able to set up the code coverage, but like on Docker, we are trying to set up that. So, any pointers which you can share that will help us during our actual setup?
Which one?
Code coverage. Code coverage we are trying to set up on the Docker side. So, any pointers that will help us to do that?
Again, easy. For code coverage, which tool you want to use? This Covertura or Graph4 Sonar? Which one?
Jacopo.
One of the tool. Jacopo maybe Jacopo.
Jacopo. Yeah.
Okay, we are looking for Jacopo. So when you are in Docker world, the very first thing you must do always, no one knows. Because Docker Hub, there are multi-million images. No one knows that images can name and images there or not. The very first thing in Docker world you should do is search from here, or by directly going into the browser UI, you can search on the directly cloud URL from there also. I'm searching whether there is an image with the name Jacopo or not. What is that? SEA. Always do this first. That should be very first. See, I have my work done already. You can see how many images already found. You see here how many images already found with the name. There are already a lot of images with the name Jacopo available. See, Jacopo volume image, Jacopo resides in. Provide the CLI tool for Jacopo. I can start from this tool, this particular any one image I can say. So that is for sure. See, why in the name you have a slash and slash and slash? It means they have been uploaded by users. When you have slash and namespace, that is username. These users have uploaded the images. So whatever image you feel like looks like little revealing to you, little lucrative to you, any image you can use to build your own image from. And then the only thing you have to do what? Let's say I start from, let's say I like this one, provide the CLI tool for Jacopo. All right, let's say I like this one. So what I'll do is I start my image from here and I will copy. See what I'll copy. I will copy the entire Java code from working directory to there, and then I will not expose anything and all. What I'll do is I'll not run anything and all. I will say come run Jacopo command line, and I would run it. I want to run it on my entire source code so that it knows that source code in the asset folder. It will run Jacopo from the command line and will generate coverage report. Just like this, actually, we need to go ahead. These are the things which you need to do. So it will do the code coverage for the entire code in that USR Java folder, and it will generate the report. After the reports are generated, if you want to expose those reports on a port number, on HTTPD server which you have already installed, you can expose them also like this. Many options you have. Well, it's very easy actually. But I'm telling you, if you work with this for 10-15 days, you will easily understand. In one container, you can have many things. In this container, I'm having Jacopo as a CLI tool for code coverage, and whatever reports are generated in the same container, I'm having the HTTPD also. And you will say, how will I get HTTPD? Very simple. I will use run. I will use apt-get install. Okay. When someone was asking me how can I get multiple things, it is actually started from this base image, but I wanted to have HTTPD server also. I am installing it actually manually by running that command, and then whatever HTML reports are generated, they are exposed via IP port number to the outside world, so that the code coverage report can be exposed on IP port number. So these things can be done quite easily. Just to give you a hint, I hope you got the hint here.
Yes. Thank you.
Main thing, search command is your best friend. Search command should be used. Don't make your assumption that I will not have a container like that. Search for it, sorry, image like that. Search for an image. If you find it, half work is done. Simple. Any more questions, guys?
So are we able to delete the image from the remote repository? So in case if it is referred by some other,
you can remove it forcibly. -f option is there. There is option called
okay. So
-f.
Okay. So what is the case if that is referred by someone else, but that image is deleted from the remote repository? I think they will get the issue sign, right?
No problem, sir. No problem. If I already have a container from the image, container is created and container is running, but I delete the image, there is no problem. Container will be running. There is no issue at all. Image is gone means gone. That's all. You won't be able to issue new containers, but that container will be running. It has nothing to do with the image. Image just a static copy which is deleted by mistake. Also, containers are there and they will be running. For sure, you can try in your local system, delete the image and run your container. Container will still run. There is no problem.
Okay, only so we cannot create the new images. I'm right from the base image since it is deleted. Okay.
Because that image is gone, so you won't be able to create new containers or other images out of it. These two things you won't be able to do.
So Ritesh, if we means Dockerize our application, then the application will be platform independent, right? We can release in the Linux environment or Windows environment, right?
Absolutely, sir. Yes. So that beauty we have of the container technology. That's why it became very popular to use this Docker. This is I was showing you on this screen. I was showing that. Yeah, here on which Docker containers, on which platform they can run. So they can run on various Linux distributions like Ubuntu, Fedora, CentOS, SUSE. They can run on cloud environment, Amazon Cloud, Azure Cloud, Microsoft Cloud, IBM Cloud. They can run on Windows, Microsoft Windows operating system also today. Not only that, another beauty, they can even run within VM also. I forgot to mention this thing. There is a relation with container and VM. The container can be run within a VM also, like we are using Oracle VirtualBox, VMware or parallel. Within that also you can use a container inside that also. So from the platform perspective, there is no problem. Everywhere they are available, and that is why Docker made container technology more popular. Otherwise, these technologies were there in the past. See, we were having a container in the past, LXC container. That time container technology was not very popular because these containers are not portable actually. LXC container or Solaris jails. There is a container technology called jails from Solaris jails. Container technology is very old, but they were not portable. That's why they were not very useful. That's why developers don't know them. That's why developer community was not very much after them. But when Docker came, they gave you Docker Hub. They wanted to ship container through Docker Hub to other machines. These are the things which made them popular and which made them reusable. See how we came to know about container technology only from Docker. But Docker is not the first container technology. There are many already. But it has given you a lot of things. That's why it made it very popular, very useful. So if you ask me, the answer is very simple. They are platform independent. You can run them on bare metal hardware machines, virtual machines, Microsoft OS, Linux OS, Mac OS, any cloud, Microsoft Azure, Google Cloud, or IBM Cloud, any cloud you can run on. Absolutely platform independent. In Amazon, there is already a service called EC2. I am sure you might have used if you are an Azure developer. EC2 service. EC2. That already help you to start Docker container and shut down Docker container. Already Docker container is there. In Microsoft, there are Docker container. In the Microsoft Cloud, you log in, there are Docker container already there. We already have container. In Azure also we have Docker container. So that platform independent, that is another beauty. That is the benefit, na? I create a container today with my code, with my environment. I'm moving my machine, or I'm selling my machine to someone. I'm breaking my machine, and I don't have to worry. My code, my environment, my JDK, my Scala kit, my Eclipse environment, everything is there. It is already uploaded on Google Cloud. I can use it any day from there. Into a new machine, I will prepare and I will again download that image and install it again. That's what. So that is the beauty that we don't have in physical machine or virtual machine. So very easily we can switch. We can switch environment. Very easily we can switch project. Very easily we can switch cities or locations or countries. But your Docker container will give you everything anytime, any day. You can download after uploading once on any cloud. Generally, though, we upload on Docker cloud only, which I used already. I uploaded my container on Docker cloud to upload anywhere. Hope your answer.
And Ritesh, like one more perspective, like security perspective, we should be covered, but like, do you want to say something around that?
See, from the security perspective, Docker containers are not very secure. Let me tell you right away. From the security perspective, you set up security management and TLS the configurations yourself. There is no security by default. They're not secure. Let me tell you. You must configure TLS certificates yourself, and you must expose TLS protocol yourself and TLS port number yourself from within a container. So make sure container that transport is TLS rather than non-TLS. Non-TLS transport is not recommended. So for that you have to copy certificate file, CS certificate file, trust certificate file, and application certificate file by using copy command. And you have to set up TLS protocol version yourself, which is easy, not a big deal, but the answer is you have to do it yourself. Transport has to be done, setup has to be done by yourself. Okay, guys, any more questions you have? Please go ahead. Otherwise, I am done from my side.
Last one. So which one is a good website to explore this Docker option? So I think you covered all the basics. That's good. So if I want to explore more on that, so which one is a good help website to explore?
Okay, this one. This one. Try this one always. Play with Docker. This one.
Okay.
Play with Docker. So the benefit here is when you're reading theory from Google tutorial, you know, there are a lot of tutorial on internet. Reading some tutorial, and when you want to practice that tutorial ke command like from command, like copy command, like add command, like Docker build command, like Docker image command, Docker rm command, for example. So don't you think you need to download and you need to set up Docker machine in your system? So if you want to avoid it, if you want to play all the Docker command out of the box, already we have labs play with Docker, login, and they are giving an interactive shell like I was using a CLI command. They are giving an interactive shell, and you can run all the command without installing anything in your machine. So generally, I prefer this one. Take theoretical knowledge from XYZ tutorial on internet and practice them here on this particular level without installing anything in your machine. Just log in and practice all the command of Docker. Play with Docker.
Okay.
Anything else, guys, you have in mind? Any other more questions? Because this meeting will automatically end after time. I don't know what time it is. It should not happen. It is automatically